I'm Kevin Cardwell. We're going to teach you how to use Wireshark to do network protocol analysis and use Wireshark to hack like a pro. I have more than 25 years as a professional security tester, and Wireshark, or network protocol analysis, is a foundation. It's a foundation of IT security. So we're going to have you download the tool from wireshark.org. Once you download it, we're going to have you install it. Once you've installed it, we're going to take static packet capture files to learn the user interface and the process of doing network protocol analysis. Once you've enhanced your skills and got familiar with the user interface, we're going to go into live capture. And a live capture, you're going to apply this process and methodology against the same types of network traffic that you've experienced in the static capture files, but these will live real time of what's taking place on your network. Then we're going to give you the process and methodology and challenge you to take static packet capture files and determine if an intrusion or an attack has taken place. Again, this skill is a foundation for IT security, and especially anybody who wants to be an intrusion analyst, professional security tester, ethical hacker, or any one of those. You can reach me at computerguru63@gmail.com. Let's get started and learn Wireshark to hack like a pro.
Now that we've looked at what the course is going to cover, the first thing we want to do is actually download the tool. So as you see here on my screen, I'm at wireshark.org. So you just go to www.wireshark.org. Over in this icon here, you click on download. Windows installer 64-bit. You can get multiple platforms, but in our case, we're just going to go ahead and use the Windows installer. So what we're going to do is, once it downloads, we're just going to install the actual tool. So we go Tools, Downloads, and we double click Wireshark. What else you really need to install? You can read through this if you want, the license agreement. It's always nice to read through this, but unfortunately nobody really ever does. So click on I agree. And then you see this is what it's going to install, all these different things. Now T-Shark is a command line version of Wireshark. But for now, this is everything you need. And also this user guide is an excellent guide for doing actual Wireshark testing. It shows you how to do so many different things in Wireshark. So we just accept all the defaults. There's nothing here that we're going to actually change. And now this is the part where sometimes people get confused. Now it tells me I've currently got installed WinPCAP version 4.1.3. And it asks me, do I want to install in WinPCAP version 4.1.3? So since it shows that the WinPCAP version that I currently have installed is the same, I don't have to worry about installing it again, so I can just accept the fact that it's already installed and click Next. Now you might actually have to install WinPCAP if you never installed it before. And install USB cap, all those types of things. This is nothing we're going to do because we're not actually doing any USB cap traffic. So again, just accept the defaults and click Install. And that's pretty much the process of installing Wireshark. And now it will install. Once it gets done installing, you click Next, and we'll click Run Wireshark here just so we open. We close out of here. And that's all we want to do in this module. In this module, we went to the wireshark.org site, we downloaded the Wireshark utility, and we installed it. And now it's actually ready to go. Now in the next module, we're going to go and we'll go into this in more detail, and we'll look at some slides and explain this user interface that you're looking at now. And as you see here, that's already reading information from the wireless adapter on this computer. Again, Wireshark, once it's installed, it starts looking at your network traffic. That's a feature of the newer version. The older versions didn't do this. And that concludes what we wanted to do in this module. Again, next step in the section, we're going to actually do the interface. And we'll review how to use this user interface and what exactly you're looking at when you're looking at a Wireshark packet capture. Now we've installed Wireshark, the next thing we want to do is take a few minutes and talk about working with Wireshark, mainly the user interface. This is how you're going to interface with the program and actually interact with network traffic. So what we're going to do is we're going to explore this Wireshark interface. We're going to look at the different components of it and how you can access different things to analyze your network traffic. We're going to start with a packet capture. This is going to be our actual static file that we're going to present to you. And that static file is going to allow you to look at different network traffic and learn how to analyze that packet capture. Then we're going to examine the window sections. There's 3 main window sections of Wireshark. You're going to learn each one of those window sections and ways you can do to enhance your analysis of the network packets that you capture on the wire. We're going to identify some resources to assist. That is, where can we go from here? So we have more material in the course, but also places you can go and learn more information about this wonderful tool. So this is the actual Wireshark interface. So when you have a look here, you see we've got Welcome to Wireshark, and under there you have these network adapters. So as you look at this image here, you see these network adapters. The wireless network connection actually has a graph on it. That shows you that the wireless network connection is currently capturing packets on the network. And all we have to do is double click that or click on capture and start our capture, and we'll be able to actually identify that. So we have 2 methods to start our packet capture. We can use the menu, capture, select options, select start, or you can just double click the network adapter of your choice. My preference is to use the capture, the options, and the start. And this is actually what comes up when you use capture, options, and start. As you see here, we have all our interfaces. I have the wireless network connection selected here. And what we do is we just click on start. Once we click on start, we'll start capturing packets. Let's take a look at it. So there's 3 main sections of the windows. We have the packet list. As you see here in the image, this packet list is showing you the source of the packet, the destination of the packet. So it starts in the far left corner with the number, and then self-explanatory, the number of the packet in the trace. And then it has the time, number of seconds ticked off between the packets, the source, in this case we have a Netgear source, and then this destination is the broadcast address. So in this case it's going to our network broadcast address. And this is address resolution protocol, which is just basically asking who has this address, tell me. And we'll look at that in more details as we expand and learn more about TCP/IP and how to conduct analysis of TCP/IP traffic. Now in the packet details, which is located in the middle window, this is where we get into the actual frame. So as you see here on the actual image, we have the frame. Encapsulated inside that frame is Ethernet traffic. And inside the Ethernet traffic, we have address resolution protocol. This middle window is where you expand and be able to look at and view additional details of the packet, a thing that we call the header, which we'll learn more about as we continue and build your skill set. The next one is packet bytes. This is in the bottommost window, and as it says, this is the bytes. It's usually represented in hexadecimal, so it's easier to look at than binary bits of 1s and 0s. So as you look at this, we see this packet bytes has these Fs. Those 6 sets of Fs means broadcast address. So now we're just looking at the broadcast address in the actual packet header itself. Now what you see here in the bytes is the destination comes before the source. That's something we'll have to look at as we get more and more detail of how to do packet analysis. So how about some resources for you? Wireshark User Guide is an excellent resource. This is where you can go, you can get information about Wireshark, and it has detailed information on how to use the Wireshark tool, including sample packet capture references. You have the wiki. So if you go to wireshark.org and you select the wiki, that's an excellent source and a resource for you to follow. SharkFest is this annual Wireshark conference that has all these great presentations and conference talks and workshops on how to use Wireshark in even more detail. So again, all these will help you learn more about the Wireshark tool. As we said, resources and references will help you become a Wireshark expert. So what we cover in this brief section of our module, we looked at the user interface for Wireshark. That is, we saw there was 2 main ways to start our packet capture. We could double click the interface, or we could do it from the menu option. We also explored how to start a packet capture. This is, once I start a packet capture, what do I have to look at? Examine the window sections. We have 3 main sections within the Wireshark interface. We looked at each one of those. We had the packet information, the packet details, the packet bytes, and more information that we'll look at as we get more and more deeper into our information tutorial. And we identified some resources to learn more. We talked about the excellent Wireshark user guide. We talked about the concepts of how you could go to the wiki and you could actually research information on the wiki. And finally, we discussed the excellent resource and reference of SharkFest. Maybe you want to attend a SharkFest, or go just look at the information at the SharkFest site and read about the conference talks and presentations that are presented there by some of the top tier talent within the Wireshark community. So now that we've done this, the next thing we're going to do is apply our skills. We're going to apply the skills we just learned and actually use Wireshark to analyze our first packet capture. Next, we're going to examine your first packet capture. We're going to use this excellent reference we've already looked at of how to actually start up Wireshark. We're going to start up a static packet capture file, and you're going to learn how to use these three main sections of the Wireshark interface to analyze and get additional information on Wireshark as we look at network traffic and analysis of that traffic. And this concludes this section. In this section, we're going to look at reviewing your first packet capture. So as you see here, we got Wireshark's main display open. So what you're going to do is, if you look into supplemental files, there's a file called file1.pcap.ng. That's an actual static packet capture file that I've created, and we're going to actually take a look at it. So all you have to do once you open Wireshark is click on File, Open, and then select File 1 and click Open. So now, before we go into this actual three main sections of the window, which is the intent here, I want to show you what this packet capture actually is. So what I've done is, in this packet capture, I went to two places. I went to udemy.com and I went to fordmotorcompany.com. Now, if I go back to this Udemy, there's an interesting thing here. Because of all the attacks, everything that's been happening on the internet, the Udemy website actually uses HTTPS, the Secure Sockets Layer Protocol, which is a good thing. So when we look at that network traffic, it's going to be different than what we see when we look at the traffic for the Ford Motor Company site, because it was still using HTTP. So now when I go into the actual packet capture and I look at my file1.pcap, you see over here is the actual numbers. So I've got the numbers of the actual packets, and then I just start looking through the different traffic. Now there's a bunch of ARP, address resolution protocol, and we'll discuss that as we get further in. That's the next section when we actually go into interpreting a lot of this stuff. But remember, this first top window is what we call the packet list. So this is the list of the packets in the trace, and these packets show what's taking place between a source and a destination. And again, we have this source of the Netgear, which is the MAC address of a Netgear device, and the broadcast, which is just going to all devices. And again, it's an ARP, address resolution protocol, which maps the IP address to the MAC address. And again, if we look at the packet list and we scroll down here, we see a lot of different packets. And this is the thing, and this is why it's so important to understand protocol analysis. There's so many packets on our network, we want to make sure we can identify those packets and analyze them. So we keep going down. There's a lot of information in here to take a look at, including there's some HTTP traffic. Remember, whenever you see this HTTP traffic, it's going to be in clear text, so we can review all that conversation. And we'll do that as we get further into our skill set. And there's some reset packets, and we'll get into what all this means. But what I'm going to do is I'm going to page down in the packet list just to show you this here, transport layer security. This is that HTTPS. So when we use HTTPS, now you see that the actual information is encrypted. So since the information is encrypted with HTTPS, that means it's going to make it more difficult to actually be able to view it. We can review usually what's called the handshake, the communication between the client and server to set up that actual encryption, but we can't view anything else. So that's the top window. Now let's take a closer look at the middle window. If you remember from our slides, we had the middle window gives us the packet details. If I select this packet right here, we see TCP. Now remember, everything starts with a frame, followed by Ethernet, followed by IP in this case, which is the internet protocol. So in the details section of the packet, I actually can get the protocol. So this is the IP protocol version 4, and it tells me the protocol type encapsulated inside of there is TCP. And then following this, I see the TCP section of the packet. So again, as we start building our skills, we want to understand how all this works, and we'll cover that in the next section. So the last thing we're going to talk about in this brief section is the bottom window. The bottom window is the actual bytes. So when you look at that bottom window, you see this is the hexadecimal bytes of that packet. Now, later on, you'll learn how to interpret these hexadecimal bytes and exactly where the start of the header is and all that type of information. For now, we just want you to see this is the actual bytes of the packet. The more you understand, or what we call the lowest level or lowest layer of the application, like the OSI model, application layer, presentation session, those types of things, the lowest level is the physical layer. If you understand the physical layer, the bits and bytes, it makes you much more powerful when it comes to either security, defense, hacking, pretty much anything to do in a career in networks. The more you understand the lowest level of the actual network communication, the more powerful you'll be. Next up, we're going to look at the exciting world of client to server interaction. We're going to look at this ARP, this address resolution protocol, this DNS, domain name server. What does all this mean? We'll cover that in the next section. And this concludes this section. Network communication. In this module, we will introduce the initial components of network communication. We review what takes place when you communicate within a network. So what we're going to cover in this section is we're going to categorize the client-to-server communication. That is, how do clients and servers communicate at the network level? Once we've done this, we're going to look at the domain name server. Domain name server takes the human readable form and prepares it for the machine. Then we're going to look at the address resolution protocol. This is how we take our information and we apply it within the network. So client-server communication. Clients use ports greater than 1023 in most cases. We consider these transient in nature, and this is because as clients, we do not spend much time in a connection. Therefore, it's transient, or another name for that is ephemeral. Think about how when you connect to a page on the internet, how much time do you spend before you click on something else? That's why we traditionally use client-side traffic as transient or ephemeral. Servers typically operate in the lower than the 1023 port range. This is what we call reserved or privileged ports. That's because you used to have reserved privileged permissions to be able to access them. So what this does is it's an open state and it just waits for connections. That is, it's a door that's open on the machine. This makes it much easier for an attacker, since they know the server is there to serve up services. That means it's always going to be there and available for an attacker. That's why most of the time, the majority of the attacks are against servers, or as you'll learn nowadays, against mobile devices, because people use them like a computer. So the domain name server, when you type in that name, it maps that name to an IP address. This is because the computer wants to draw the raw data of binary ones and zeros. It does not care what the actual readable name is or if a human can read it or not. Remember, all computers do everything in binary. They want that IP address in ones and zeros. This is the language of the machine. Everything is in binary. To it, it doesn't matter what it looks like other than ones and zeros. Traditional IP address we see is represented by 4 decimal numbers. This is what we call dotted octet. That's because it's 8 bits of binary for each number. This example here we show is how humans typically view an address. It's 192.168.0.128. That's what it looks like to a human. This is what it looks like to the computer. This is 8 bits of binary for each number. As you see, the computer doesn't care about if we can read it or not. So when you look at those binary numbers, the ones and the zeros, it makes it a challenge to read. So for our purposes, we like to use hexadecimal representation of this. And this is the IP address in hexadecimal. That is, it's C0880080. This is how, when we start doing our protocol analysis, we want you to look at it. We want you to always look at things as if it's in hexadecimal, which moreover is binary, but we're not going to task you with trying to learn all those ones and zeros. It's much easier to look at 2 digits in hexadecimal, which represents 8 digits in binary. So this is easier. Some might be saying it is not, but trust us, once you practice, you'll be able to convert between the decimal and the hexadecimal as easy as writing your name. Now we come to address resolution protocol. Now, address resolution protocol is how we map the actual IP address. This is the main protocol for getting the data into the machine. The IP address just gets the data to the network. That is, it gets it to the data or the wide area network device, usually in the form of a router, that belongs to that local subnet. We need the MAC or the physical address to send the data into the machine. And this is how we use ARP. The address resolution protocol gives us that physical address to send the data into the machine. In this section, we've defined client-server communication. That is how clients and servers communicate. We have explored DNS and how it maps the name to an IP address. Remember, computers only care about binary, ones and zeros. They don't care about the numbers or in a human readable form. We enhanced our skills with information on ARP, the address resolution protocol. Remember, ARP is what we use to get us the physical address. And the physical address, or that MAC, that media access control address, that is the required address to get the data to the machine. Next up, we will explore these protocols and you'll get to look at the file 1 static packet capture file. Now we've discussed the theory for client and server communication. We will now apply our knowledge and skill to the static capture file that we've created, file 1 pcap.ng. You can open the file to follow along and complete the steps as I do, or you can watch first and then do it when you watch it again. So we just click on File, Open, and we find our file 1 pcap.ng. So once we open it, it will open up, and you see here we start off with packets, and on the left column you have the numbers, and then we've got all this ARP traffic. But before we get into that, what we want to do, we want to look at our DNS. Remember, DNS, domain name server, takes our name and converts it from human readable form to machine readable form, which of course is binary. So what we want to do is we want to go down here to where we find some DNS traffic, and we'll go through this several times, so you'll get to look at it quite often. So, and we'll show you quicker ways to do this. For now, we're learning the basics. So what we're going to do is we're going to look for a specific packet because I've researched this trace already. So now I come down here, and here's the packet I want. This 1093. So as you see here, we have www.udemy.com. That's the DNS query for the Udemy website. And in the middle window, you see here we have a source port which is greater than 1023. And we have a destination port which is 53, which is what the domain name server or DNS resides on. This points to the fact that clients normally use a port greater than 1023 and the service is less than 1023. Next thing we want to look at is the DNS information itself. So we click to expand this section that is called the domain system query. And in the query, it has a question. And that question is exactly what you probably think that question is. It's www.udemy.com. So when we look at this question, we see www.udemy.com. That's the question going to the server. So what we want to do is we're going to actually look at the actual query. We have that, and we got what's called type A for address record and classes and internet record. So now that we've looked at the query, what do you think we want to look for next? The response. So it's the very next packet, which makes it easy. So now when we look at the response, we see that the only difference is located at the bottom. There's the query, but in the response, we have this answer. And the answer comes out and gives us www.udemy.com is at this IP address. You can see here this 151.101.24.175. That is the IP address of the Udemy server. So now that we have that, that is actually replaced in our browser transparently to us, but it's replaced in our browser, and now it goes out and connects on that IP address to the server that's located there. Okay? Remember, the IP address is what the machine needs to get it to the correct location. So we return to our top window. We see right after the response, which created the machine readable form, we go into a series of connections to this port 80. Now we'll discuss what that is in the future, but right now, just understand that's a request to that web server to talk to me. And that's really what the main thing is. So now that we have this, we want to look at an example of ARP, the Address Resolution Protocol. Now ARP is local, so we'll not see the ARP for the Udemy server, but we have a number of ARP packets we can review. If we in our file locate packet number 3708, so we come down here, we'll page down, and we look for packet 3708. Again, we'll teach you a quicker way of doing this once we build your skill set. But right now, we're looking right there. And we see in packet 3708, the source MAC address is coming from a machine, and the destination address is representative of all these Fs. These Fs are the broadcast address. And you see, it's basically a question. Who has 192.168.0.7? Tell me. 192.168.0.1. So once you see this, you know that packet 3708 is the request. Well, where's the response? The response is here at packet number 3714. As you can see here, 192.168.0.7 is at MAC address in the hexadecimal again, CC3D821E514F. Now we have the physical address, and now that machine can receive data. This is the information for the packet ARP. So if we click on this, as you can see, the middle window now has Address Resolution Protocol. And if you look here, there's the MAC address. So now it tells you the IP address and the target MAC address. Now we have all this information that we've analyzed just in a couple of simple clicks of and looking in the tool Wireshark. As we said, it's much easier to represent the IP address in hexadecimal, because we go here, there is the target IP address in numbers, but rather than looking at it in binary, we have it here C0880001. In this section, you have verified how client and a server communicates, and how DNS and ARP network traffic look like in Wireshark. One important thing to note here is that the entire process we have discussed, ARP and DNS by default and in accordance with the protocol, do not have any authentication. So the source of the packet is trusted to be whom they say they are. This is one of the biggest reasons we have all the attacks and all the hacks and the things you hear about in the news today continues to be that the protocols all are based on what's called the principle of trust. Now, the newer ones that we started to add to and stuff like that is changing that. But the hackers today still can use this principle of trust to their advantage when they conduct their attacks. Next up, we will look at your first protocols. And this concludes our introduction into client-server communication analysis. In this section, we will explore the main protocols that you will encounter on the network. We will explore the protocols in the following order: ICMP, UDP, followed by the dominant protocol, TCP. Once we've done this, we'll look at how these characteristics work in Wireshark. So ICMP, Internet Control Message Protocol. This is the protocol to communicate messages within the network. Some of the protocols do not have the capability to acknowledge and subsequently provide reliability, so they use ICMP. The most common form of ICMP is probably ping. This is the same ping that's used in sonar, and that is sending out a transmit request and waiting a return from a receiving target. Within our networks, we use two components. That is an echo request and an echo reply. This achieves the successful ping. So what that is just like sonar, we send out into our network a transmission and we look for a return. If we get the return, our network is reachable. Despite most being aware of the ping type of ICMP, there are many different types of ICMP. This is so it can provide messages for those protocols that require assistance. The ICMP type 3, also known as destination unreachable, it's very important because it lets us know if something is unreachable. This can show a multitude of different reasons for the destination being unreachable. How do we know which reason it is? There is a subtype called a code. This code will tell us why it's unreachable. One of the most common one that we will encounter is type 3 destination unreachable code 3. This means the reason it's unreachable is the port's unreachable. We also have type 3 code 13. Code 13 means the packet is administratively prohibited. So as you can see, these types, and especially the code types, can assist us in troubleshooting our network. And more importantly, knowing that in the case of identifying information for a security test or those types of things, a filter in place, if we send out an ICMP request and get back a type 3 code 13, that means we have some type of filter or a network router with an access control list in our path. The next protocol is UDP, User Datagram Protocol. As you may recall, it's a connectionless protocol. That is, it's not reliable and there's no guarantee of delivery. And that's the way it was designed. The best analogy for this is the mail system. When you mail a letter, there's no guarantee of a delivery. We take it, put it into the postal box or at the post office, and we rely on somebody else to deliver it. This is the same thing we do with UDP. Primarily use UDP for speed. And now we have TCP, Transmission Control Protocol. The main protocol for most of our network traffic we will analyze is that of TCP. This is because TCP is primarily used in majority of the different protocols. It provides us that reliability that we need for network communications that require it. Remember, we have the guarantee of delivery. We get this guarantee of delivery by an acknowledge capability. That is, when the data goes out, we receive an acknowledgement that the data was received. Once we receive that acknowledgement, we continue on with the data. As you can imagine, this requires additional overhead, so TCP can be used for guaranteed delivery. This overhead, of course, comes at a cost, and that cost is speed. That's why UDP is used for our streaming protocols. TCP also allows for transmission from both sides of the connection. That is, it's full duplex. The data is transmitted as a stream of data since the connection-oriented sets this up for us. Remember, we establish a connection because we have the acknowledge capability. We transmit as a stream of data, and we'll learn more what this means as we look at it in Wireshark. In this section, we have taken a look at the workhorse protocol, ICMP. We've looked at the connectionless protocol of UDP. Remember, UDP, no guarantee of delivery, like our mail system. We closed out the session by briefly looking at the reliable and connection-oriented protocol, a TCP. Remember, TCP primarily is what we're going to use when it comes to the majority of our analysis. Most of the traffic will be under TCP protocol. Next, we will explore these protocols, applying our skills we've learned in the tool Wireshark. Now that we've reviewed some of the network protocols, we're going to apply our knowledge and skill to this static packet capture file, file1.pcap.ng. You can open the file again if you want to follow along and complete the steps as I do. So it's pretty easy to do, and once you've used it, Wireshark keeps it here in a history. So we just open up the file. Now, the packet we first want to work with is 8217, so 8217. Now, that's a little bit far down into the trace, but a shortcut is just click into the capture here at the top window, hit Control and then the End key, and that takes you all the way to the bottom of the packet capture. Now, if you look here, we see packet 8217 right here. And over here to the right, you see echo ping request, and then it's immediately followed by packet 8218 echo ping reply. And what that tells us is that's our ping. So a request has went out from this host 192.168.0.7 out to that IP address. And that IP address you might recognize. This IP address is the IP address of the Udemy web server. So now we come down here and we look at the middle window. So if I expand the ICMP, you see, in fact, ICMP echo request is actually type 8. And if we go look at ICMP echo reply, it's type 0. So that's what I was talking about, how we've actually got the capability with ICMP to reflect a lot of different things. So now that we've explored ping, let us look at one more type of ICMP. Remember we said that some protocols use ICMP to notify the network about a communication status. We mentioned one of the more common ones being ICMP type 3 destination unreachable. So if we go to packet 1241 here, and I'll just control home to get to the top again, and then scroll down here to 1241. Again, we'll teach you a quicker way here soon. And that in black is highlighted. So when we look at packet 1241, we see this is an ICMP 3, right? ICMP type 3. So if we scroll to packet 1241, we see that this is an ICMP type 3, destination unreachable, and a code 3. And right here is both of these. We can see it in the top window, but in the middle window, it shows it to us as well. We have a type 3, destination unreachable, and a code 3, which means it's an actual destination unreachable, port unreachable. Well, what's that little trick that we were saying we were going to teach you? It's time to teach you that now. So anytime you need to get to a specific packet, as we're reviewing here and building our packet captures, looking at static packet capture files, just click Go to Packet. And then you put in the packet number. So when I put in packet 1241, it goes to packet 1241 and highlights it. So that makes it a little bit easier to do our protocol analysis. So 1240 is the actual request, which was a DNS, domain name server query. So as you see, this was a Udemy request, but it was responded to with an ICMP type 3 destination unreachable and a code 3. Why? Because this request went to port 53. Remember, that's a door on the machine, and that door was not open. Right? So when you look at this packet 1240, we know that this was a DNS query and it uses UDP. So if we go in here now to look at some UDP traffic, so we click on the 1240 packet, there's UDP, and then we look inside the UDP portion of the packet. So as you see here, this query actually comes back with a response, 53, right there, in the destination port, right, in the domain name system response. So again, we're identifying domain name server information, and there's the answers and the queries and additional information here that you can explore and learn more. Remember, the most important thing we want is to identify what took place on the network. And in this case, it was a DNS query and a response of the DNS information, right? So this is a query response. And this here is a destination port unreachable, which means we tried to go to a port in this case, and it was not available. It was not open. So that's UDP. As you see, there's not a whole lot of packet details in a UDP packet. Remember, that is because it's connectionless and doesn't guarantee our delivery. Now let's look at some TCP communication. So now let's go to this packet 1239, which is TCP right here. All right, so when we look at it, this is an actual packet that's using protocol TCP. So if we expand it here and we scroll down to the flags, we see it has this ACK flag set. All right, so that allows for that reliability and guarantee of delivery. We're not going to spend too much time on this here because we'll explore it in great detail throughout the course. Remember, the more we get skills and the more knowledge and information we cover, we'll continue to build our skills to a more defined and process-based level. That is, we're going to learn how to analyze this and determine what takes place, in this case with TCP. As we said, TCP is our predominant protocol, and we'll actually have that in quite a few of our examples. So now let's look at the packet details. So now if we expand to TCP, we looked at the flags, And now we're going to expand the flags. These flags, as we'll learn in future exercises, are the control bits of the communications of TCP. This is how TCP has that guarantee of delivery and reliability. So we'll stop here and continue on with another section. Next up, we'll continue with building the TCP/IP skills foundation, and that will be in the next module. In this section, we will explore the foundation of TCP/IP. That will include a review of the headers and the concept of encapsulation and how it looks on the network. We will learn about the network protocols. Following this, we will examine the encapsulation process and what it means on the network. Then we will close out this section with a brief exploration of the headers of the different protocols. The internet was built with an openness and trust. Part of this was the creation of protocols for communication. These protocols were when the internet was very small and there was no need for protection. So this led to the protocols being developed with this sense of trust. Then today, more than 40 years later, we are still running these same trusted protocols. Therein lies the problem and why there are so many attacks today. These protocols were not made for a network of the size that we have today. There is a requirement to provide information to the network at each layer of the communication. This is in the form of a header. This identifies the data to the receiver, and it's essential that we understand these headers. They are the key to what's taking place within the packet. Within the network, we have this process of wrapping the information within things, encapsulation. Everything within our network is encapsulated. Each layer has its own specific function for each header for this. This is an example of the OSI model in encapsulation. So as you can see here, each layer has an associated header that identifies what's taking place. This continues until we get to the physical layer, which is our binary ones and zeros. Encapsulation. We now want to look at this in our tool Wireshark. As this image shows, we have the data all encapsulated within the frame. This is followed by the Ethernet, and then the IP, followed by the encapsulated protocol, which in this example is UDP. This shows us how the network protocols are contained within one another. In this image, we're looking how the data flows between machines, and more importantly, between the layers of the network model, both logically and physically. Physically down the stack and then up the stack from the sender to the receiver. At each layer logically, the same function is taking place within the sender and the receiver. This is the IP header. This image shows the IPv4 header. And what we want to look at here is this, the protocol field. This is where that encapsulated protocol is identified. This image shows the UDP header, and as you can see, the header is very simple. Again, this is because it's connectionless and does not require any method to provide reliability. So it can be simple, as you see here. We have the source port and the destination port. This identifies the data to the service that receives it. This image, we have the TCP header, and this has quite a bit of data within. That's because we have to maintain that guarantee and that reliable service. We will not review all the information here. For now, we will look at the fact that it has the same important information as that of the source port and the destination port, so it identifies the service to and from. It also has these two fields for sequence and acknowledgement number. This allows for the connection-oriented requirement. Finally, within this header, you see these here. These are the flags or control bits of TCP. And each one of these identify additional details about the packet. In this section, we have explored network protocols. We explained and showed examples in the encapsulation process. We closed out the section with a brief look at the headers of the different protocols. Next, we will explore the information with a static packet capture file within the Wireshark tool. Now that we've discussed the theory for the network protocols, encapsulation, and the headers, we'll now apply our knowledge and skill to the static capture file, file2.pcap.ng. You can open the file to follow along and complete the steps as I do if you would like. Once the file opens, as you see here, we have it open. We first want to look at our IP header. We want to select this packet number 3. Once we've selected that packet, we notice that it is an ICMP packet. And look at the middle window. We see here we have a frame followed by Ethernet, followed by IP, followed by ICMP. So again, that shows our encapsulation. All of this is encapsulated within IP. This is what we mean when we say all protocols are encapsulated or contained within each other. In the middle window here, if we expand this section of the IP, the Internet Protocol, we can see more information. So if we highlight here IP, we see down here in the bottom window, all highlighted in blue, that's the entire IP header. It's represented in hexadecimal, as we said. It's noted here with the start, so if we click on the version 4, that 4.5 signifies the start of the IP header. So remember, it's easier to read this in hex than in binary. So now if we go down here and we click on this protocol type, we see that the protocol type ICMP is represented with a decimal 1. That's what we're showing here. So that decimal 1 highlighted in blue in the bottom window tells us that the IP has the encapsulated protocol of ICMP. Now if we go to packet number 5. Now in packet number 5, this is a UDP packet. It's encapsulated again with the IP header. And we see this right here because UDP is hexadecimal 17, or highlighted in blue. We don't have a 17 in hex, therefore it's represented by an 11. So if we look here and we collapse this again, you see IP has the encapsulated protocol UDP, and contained within that is data. So if we expand UDP again, we see it's a very simple header. Why is that? Because it's connectionless. And since it's connectionless, it's a more simple header than what we have when we look at TCP. So now let's take a look at TCP. Now if we go to packet number 17, so we come up here to our trace, and we start seeing some packet traffic here, packet 17, which is going to port 21, which is TCP. So now what we want to do is right here we see IP with the encapsulated protocol TCP. So if we click on the IP and we expand it, we see the protocol that's encapsulated right here represented is in the bottom window with a 6, which is representation for TCP. So this tells us TCP in fact is the encapsulated protocol. Now if we scroll down to where the protocol is located and we expand that, and we scroll down, you see there's quite a bit of information contained within a TCP header. And that is so we can do our connection oriented. And mainly what we want to focus on is these flags. And we see here the send flag, or synchronize, which basically says open a connection with me. And we'll discuss that as you get more skills, right? We can expand that. Remember from the slides, we showed you the control bits or the flags. As you see here, these are the main control bits or flags of TCP. Right here is the main ones we're going to focus on: urgent, acknowledgement, push, reset, send, and fin. Right now we have a send flag set. You'll understand what that means when we build your skills a little bit further. These flags help us determine normal and abnormal traffic, as well as a few other things as well. In this section, we reviewed the network protocols and we verified encapsulation. Next, we will review details of the connections that take place within a network and identify different characteristics of the network communications. In this section, we will explore the connections within the network using the different protocols. We will review the UDP connectionless protocol. Following this, we will examine the reliable protocol of TCP. Then we will close out this section with an exploration of streams of both UDP and TCP. UDP, this is our speed protocol, the one we use for streaming. Connectionless, it consists of a very minimalistic header. And there is no acknowledgement of the data that is received by the receiver. That's why it's connectionless. Now in TCP, our reliable protocol, we have a larger header so we can track the connection parameters. This header provides us with the sequence and acknowledgement number, along with the control bits or the flags of the connection. The reliability is provided by the ability to acknowledge or act the data that is shown here in this image. It might be surprising, but both these protocols have streams, and we can analyze these streams to determine what is taking place, and more importantly, reveal the data within some cases. You can see that UDP data is viewable, and we can determine that in this case, we have the Google Chrome browser, and it's running on Windows. All of this information is contained within the data of the packet. In this next image, we have the communication stream for TCP and the FTP communication. As we can see here, the entire content is in the clear. We will get to explore this in detail in the next section, but as you see, the username and password in this stream have been compromised. In this section, we've explored connections and components within the networks. We took a look at both UDP and TCP. We closed out the section with a brief look at the streams of data when the different protocols are used. Next, we will explore the essential components of streams and how to determine what is taking place within our static packet capture file using the Wireshark tool. Now that we've discussed the theory for the network connections in the streams, we will now apply our knowledge and skills to the static packet capture file, file 2, pcapng. So as you see here, I have the file open, and once it's open, we first want to look for a UDP stream. We have a couple of UDP packets here early in the capture. We want to look at the one that's representation of SSDP, which stands for Simple Service Discovery Protocol. We can find this at packet 59. So if I go here and go down to packet 59, I click on it as I did before, you see that it is UDP and it's SSDP, Simple Service Discovery Protocol. As you see down here in the middle window, it says Hypertext Transfer Protocol because it uses similar parameters. As you see, here's our user agent, that Google Chrome that we looked at before. So we can look here and analyze it this way, or Wireshark, being the powerful tool that it is, allows us the capability to follow the stream. So all we have to do is we click it, we just right click, follow UDP stream. This will show us the entire conversation. And there is the ASCII text or the clear text of the entire conversation of the SSDP protocol. As you see here, Google Chrome version 52 running on Windows was the browser that made this SSDP request. So just in this simple technique, we've identified somebody running Google Chrome version 52. Now, if I was an attacker, I might go look for an actual vulnerability in this version of Google Chrome. But again, that's a topic for another time. So now if we close this, we want to actually clear our filter by clicking the X here. That brings us back to the normal thing. Now what we want to do is take a look at a TCP stream. To do this, we go to packet 17. So here's packet 17. And you just see here, I have a TCP send packet, and it's to an FTP server. All right, so now what we want to do is packet 18 and 19 is part of this connection. This is that connection we've been talking about for connection oriented. We have a SYN-ACK, followed by an ACK. This is what we call the three-way handshake. This takes place before any data can flow in TCP connections. So now that we have the actual TCP identified, we can right-click the packet, follow TCP stream. As you see here, now we have the stream of data for that connection. And located within here in blue is what the server says, and what red is what the client sent. As we can see here, we have the username and password of the account being used, since FTP, File Transfer Protocol, is one of those original protocols based on the principle of trust. Therefore, everything's in clear text. We also at the first line can see the version of the server that the machine is running. All of this are things that can be used if we were looking at this from the perspective of an attacker. It provides too much information onto the network. It's best to suppress this if possible. We can also see the port command. This is the method of how a file is transferred to FTP. Finally, we can see the file that the user has copied from the server. In this case, mail.gif, GIF. So all of this we found just by understanding how to use our skills and manipulate the data using the Wireshark tool and the user interface. Very powerful. Now you can see how exciting it is to see what's running on the network. Next up, we will continue with enhancing your skills, and soon you will do a live capture of your own and be able to determine what's taking place on your network. In this section, we will review the details of the different options for capturing your network traffic. We will learn about selecting the interface. We want to select the interface that's connected to the network we want to monitor. With the latest version of Wireshark, we can select more than one interface at a time. Before we start our capture, we want to view the configuration options. Then we will close out this section with a brief exploration of the different options that are available. When you open the Wireshark tool, all the detected interfaces will be displayed. The key here is the detected. If it is not there, then the interface was not detected. This could be a problem with the driver, but can also be a problem with the host-based protection software that is on the machine. As this image shows, we have a number of interfaces here on this machine, and we see the activity on 4 of them as well, represented by the bar graph. We have a number of options when we configure our interfaces. Once we've opened the capture options, this is the default landing page of that. Once you load on this default landing page, you can see in the image we have the interfaces listed, as well as a box down here for promiscuous mode, which means the address filtering for the MAC address is turned off. Also, we have 3 tabs at the top of the listed interfaces. The output options, you can see when you can save the captures with different extensions. This extension of PCAP is if you want to review files with other tools like TCP dump or the older style of protocol analysis tools, or even the intrusion detection tool Snort, which will read PCAP files. With these options, we can set the file size, and when that is reached, we will automatically create a new file. This is good for doing monitoring for sites where you're going to maybe try to detect 24 hours a day, 7 days a week intrusions. This will automatically create a file every time it reaches that size. So you will have an actual history over that time. We even have more options. Here we can select a number of different thresholds, but what we want to focus on is the fact that we can resolve the network names. As you can see here, we have these name resolution options, and each one of these can change the information that is displayed in our capture. In this section, we've explored the selection of the interface. We've examined the configuration options that we have available, and we've noted there are a number of options that are available. When we do a packet capture, we have a lot of these different options that we can do. Next, we will explore this and set up your first capture using the Wireshark tool. Start the Wireshark program. Once it opens, verify your interface that's connected to the internet is listed. In my example here, this is the wireless interface. Once we've done that, we click on Capture Options. And as you see here, we have wireless network connection, and it's even got some data on it as you represent with the traffic in the bar graph. Now, once I've selected my interface, I'm going to click Options. What I want to do is make sure this name resolution is turned off, right? We want to make sure there's no check mark in this resolve MAC addresses. Now, that's on by default, so if you haven't done this yet, if you do your packet capture, you will see the vendor name instead of the MAC address itself. We want the MAC address here. Once you've done that, now we click on Start. Now it's capturing packets. And if you see, it'll start showing MAC addresses and not the vendor names, which is what we want. Okay? So now what we want to do is go to a website. So you can open the browser of your choice. I'm going to open actual Firefox. I'm going to go to Udemy. Now that I went to Udemy, I go back to my Wireshark, and I go Capture Stop. Now what I want to do is start looking at the skills we've learned so far and locate the DNS query for Udemy. Once we have found that, then we can look at the connection. So where do we have the DNS query at? Well, it's a little bit of a process, but usually the quickest way is to just, and we'll show you another way later, and here it is at packet 106. Now, the reason we want to do this is because you see the query, and immediately we find a response. All right? Once you get to query, once you get to response, then right here starts that TCP connection. Now, there's some DNS stuff that happens in between here. Unfortunately, that's what happens anytime you go and open a browser, because so many people are connecting and doing different things on your network. But as you see here is, it's going, this send packet, it's going to port 443, which means Udemy is using the HTTPS protocol instead of HTTP. So the data is encrypted. So let's see what happens when we right-click this send packet. Now remember, all the data is in what's called a stream. So if I right-click this and go follow TCP stream, there's all the data within the stream. Even though the data is encrypted, we can still see some of the information that's taking place. Like we can see this signature here of global sign, cloud SSL, secure sockets layer, California, San Francisco. So we got different things we can pick up as we look down in here. And there's a lot of different things to look at. But again, this is encrypted. So we'd rather, here as we start out, look at one that's not encrypted. So what we do is we close this, we click on capture, start another capture, continue without saving our packets. Again, it's going to start to capture at the same place we had before. And now we're going to go back to our browser, and we're going to go to Ford.com. I know from research Ford's using HTTP and not HTTPS. You can use any of your own websites to experiment with. So once I've connected to the website, now what I want to do is go back to my packet capture and stop it. And then I got to look for the DNS query. So we go through and we got a lot of data. My cable modem here is making lots of noise this morning. Right here, www.ford.com, right there's the query, right there's the response, and there's the send packet for the three-way handshake. Now, since it's not connecting to port 443, we're connecting to port 80, which means it's in HTTP, Hypertext Transfer Protocol, not encrypted. So now if we right-click, again, all our data is represented on the network in streams. So now if I right-click it and I go follow TCP stream, now we can see information here. Here's Ford.com, which I typed in because remember, I'm the actual client, and the client's represented in red, and the server's represented in blue. And you just see a lot of good information in here. As you see here, it's setting up a cookie, and I am in Palos Verdes Peninsula in Los Angeles County, and it's picked that up and set a region code cookie on my machine, which is again why so much data mining takes place on the internet. Now, of course, there's ways to get rid of that, but that's another topic. All right. So we don't have the type of server we're connecting to, and that's a good thing for security. A lot of times, we'll actually pick up the server that we're connecting to. In this case, there's no server leakage. So in this case, the people who set up this web server has done a pretty good job because there's not anything that I can detect as a type of web server, which is information leakage. And we don't want to leak that type of information with defense. We want to leak as little as possible. Now, one last thing we'll look at here before we close up this section. Right here, I can select different options. If I just want to see the server, I just click on this drop down here. I'll show you again. Highlight the area in blue, which is the server, which is usually represented by an address that's not a private address. My address is the 192.168 address. And then when I do the other one, this is the client. So again, this is all the information that's taking place from the client. And you see here the user agent, those types of things, identifies that in fact I'm using Firefox, and I'm using Firefox version 43. So again, now that you understand how this works, you've done your first live capture. So now you can capture anything on a network and analyze it and detect or determine what is taking place. And that's the power of protocol analysis using Wireshark. Next up, we'll continue with more hands-on protocol analysis with Wireshark. We'll give you even more skills to look at the data. Once again, we want to open Wireshark and we want to start our capture. But first, we want to look at one thing. So if I click on Capture, Options, and I look down here, you see this Enable Promiscuous Mode on all interfaces. What that does is it tells the network adapter to turn off its MAC filtering and capture all packets. Since the majority of you will be connected to a switch, we're only going to see the traffic to and from our machine along with the broadcast traffic. Where this promiscuous mode comes into play is when you have a hub or something that is sending all of the network traffic to the machine. Then in promiscuous mode, we would see all of the network traffic. One other place that this can come into play is the time when you have a wireless network adapter. Older versions of Wireshark would require the card not to be in promiscuous mode to see the Ethernet traffic. This newer version does not have that problem. If you encounter an older version of Wireshark, and in the case it's not capturing packets, that might be the actual cause. So now I'm going to start a new packet capture. I'll select my wireless network connection. Remember, we want to discuss a process and methodology for reviewing the data. We will briefly visit this here, and as we continue to build our skills, we will enhance and hone our process. So I'm going to go to a couple of websites now and generate some traffic. I will continue with my theme of cars. So I'll go to my browser, and I'll go to astonmartin.com. I'll go to Porsche.com, Jaguar.com, and Maserati. Now I've went to multiple websites. So now what we want to do is we're going to look at these websites. Remember, if you're following along, you can use any websites you want, and the process is going to work. And that's the key, is the process. So now I'm going to actually stop my packet capture. So what we're going to do is I want to go all the way up to the top here at packet 1. And we got our UDP, which is our SSDP, and we got all this ARP traffic, which normally you wouldn't see on a network. So I have to investigate that. Something's going on with my cable router, so I'm not going to worry about that right now. And as I go down here, I'm looking for the UDP traffic. So we know we want is a DNS query for our network traffic. There's a number of other DNS queries. So the first steps, we want to review the communication parameters. We look for the DNS and then move to the packets. There are different ways to do this. I like to use the bottom window, and it comes with practice, but as you look at practice and you do things, you get used to exploring the network traffic. So again, there's my Aston Martin. So there's my query for astonmartin.com. So remember, after I get the DNS query, shouldn't take that long to get the response. There's the response. Immediately following this, I get information for the connection. So it comes with practice, but more you work at it, you'll get better at it. So I said there's different ways of doing it. So I'll pull this bottom window up. So we have it here in the information block of the upper window or the top window for the Wireshark tool, but we also have it down here in the details block, which is the hexadecimal dump. So we got it either place. So which one you use is entirely up to you, of course. But now we have the IP address of Aston Martin, right? So we have a lot of different things. So this is the Aston Martin. So it's not encrypted. If it was encrypted, I wouldn't be able to read it. But in this case, we see the send packet, in this case for Aston Martin, and the three-way handshake is going to port 80. So HTTP, Hypertext Transfer Protocol. So all I'm doing is looking for anything that might be of interest. Remember in the static capture file, we had FTP traffic. So we came across that with FTP, File Transfer Protocol, the data is in clear text. So here what we're looking for is the data with Aston Martin. So now I just right-click the send packet, which is right here after the query, and I use my methodology of following the stream. So now we get in here and we have information. Remember, red is the client, blue is the server. And we see right in here, we see what? We see that they're running on their server Microsoft IIS 8.0. So again, this is all data and information we've been able to obtain because we have a process and methodology for doing protocol analysis. So now if I close out of this, I clear my filter, and I continue my little quest. So I scroll down. Again, that's my Aston Martin. And we'll show you quicker ways to do this as we go through different things. And there's all this stuff that comes along with going to a website. As I said, unfortunately, that's all part of your data mining. So we keep coming down here, and we'll learn filtering is the way to do this quickly. And we'll learn that once we get into more analysis. And again, as I said, all this information is what's taking place every time you connect to the internet. It's why if you've ever went and you've done a shopping and you've bought something or just looked for something online, curiously, every time you go online, you'll start seeing those types of things. The best example of that, I needed a computer laptop bag. Mine broke when I was on travel one time. So I was looking one night trying to find one. And the next 3 days, all I seen was advertisements for luggage, laptop bags and luggage. So again, it's all data mining. Data mining is taking place every time we go on the network today. And this is what we're looking here in the network traffic. You're looking at all the things taking place at the network level. This is why it's so important to understand how to do protocol analysis. All right? So different types of things. So once you've had the process, now you can look at different things. And again, as I said, we will start looking at this traffic with a process and methodology that allow us to give us filter. A lot of different filter and information. All right? So a lot of things on this network. So as I scroll down, I'm just looking for any suspicious. Now I got some suspicious traffic coming up here. So now the Wireshark tool is helping me, telling me, hey, you got some duplicate acknowledgments. Now that could be a spurious retransmission, as it says here. Again, it would require more investigation. But in most cases, it's probably just noise on the network because we have a lot of noise on any of our networks today. Because again, data mining. All this comes from data mining. So as you see here, all this noise is taking place on the network. Now, once we get into the next section, we'll teach you how to filter this and only look at specific components of what's taking place on the network. And that's one of the powerful things to do. So if I go here and just click on an example in this HTTP, which is a JPEG. So in this case, there's a JPEG file coming across. So now if I apply my methodology, identify the TCP traffic or UDP traffic, right-click it, select Follow TCP stream. Now there's all the data there. And this is, again, is Aston Martin, CDN Aston Martin. So it's a little bit different Aston Martin than the Aston Martin I looked at before. And it's a referrer from Aston Martin. So if we scroll through here, we have all kinds of information that's taking place. We even got this Adobe Photoshop, and we got this guy Norwood, Pete Norwood. We got all kinds of stuff in here. Adobe, all kinds of data. Again, this is nothing but network traffic that's taking place between my machine, and in this case, the Aston Martin server. So that's the power of doing this stuff. You actually learn how to actually do protocol analysis. And what protocol analysis does is teaches you what's taking place on the network. So as you build your skills, you'll get more familiar with this. And like anything else, you got to practice it over and over again until you get proficient at it. That's how we learn. Next up, we'll work with capture files themselves within the Wireshark tool and explore more ways you can filter that data to make it more granular so you can get a good look at what's taking place on the network. In this section, we will review the details of different options for working with the captured data from the network. We will learn additional information about the saving capability within the tool. Then we'll review the different file saving formats. This is powerful because you can save your captures and use them in a number of different tools to explore different things. Additionally, you can take that saved packet capture and you can use it to train and build your skills. It's all about practicing this process and methodology over and over again. That's the key. So as this image shows, we do have the capability to save any of the data that we have captured within Wireshark. This is extremely valuable when we want to set up different types of network traffic and then see what it looks like. Remember, the more you practice at capturing information in network traffic, the better you'll get at doing analysis of this. Save capability to gain more skills. This can help us to analyze data and prepare us for conducting intrusion analysis, as well as a number of other things. Again, it's very powerful when you run a network traffic capture and then you save it and get to analyze what actually took place. Remember, the more you understand the network layer, the stronger you become because your skills are at a lower level. The lower level of the network model that you understand, the more powerful you will be. We have many file formats as this image shows. The latest format is this PCAP-NG, and that will be the default format. The other format that we have here, highlighted in blue, the first format, is the most versatile. That is the PCAP format. This allows us to use the command line tool, TCP dump, and others. So if you want the most versatile format, then we would use this one. It also would allow us to import our actual packet capture file into a number of tools, like we discussed, like snort and those types of things. As you look at all these different formats, you see we can even do Nokia. There's a Nokia format, so we can use a Nokia phone. There's formats for Solaris or Sun Snoop. There's formats for NetX-Ray, which is a tool we use in network forensics. And there's even formats for Microsoft's NetMon. Microsoft's Network Monitor has some very good features and things in it as well. In this section, we've reviewed the saving capability of Wireshark. We've examined the different save formats and explained the default and the most versatile format for our packet captures, and that is the PCAP format. The PCAP format allows us to use a number of tools to do further analysis, like intrusion analysis, or even run it through a tool like snort to look at if there's any intrusions detected within the packet capture file itself. Very powerful. Next up, we'll explore this and you'll learn how to save your capture files using the Wireshark tool. So we want to start the Wireshark program. Once it opens, verify your interface is connected to the internet as shown. Go Capture Options. In my case, it's the wireless network connection, and I'm going to start my packet capture. So now what we want to do is generate some network traffic. I'm going to go to my browser of my choice, and I'm going to use Firefox again, and I'm going to enter some data. The main one I'm going to enter is that Aston Martin site again. Now, once I've went to the Aston Martin site, I'm going to return to my packet capture and stop the packet capture. Now, we've already seen that the Aston Martin site is providing us with a lot of leaked information, as we're also getting all this ARP stuff. So what I want to do is I want to actually save the information. So we're going to actually save it, this entire packet capture. So I save it, and here's where we get into the format. Now I want to keep it more versatile, so I'm going to click on the drop down, and I'm going to save it as a PCAP file. Remember, we said the PCAP file would allow us to different types of things, and that's why I save it as a PCAP file. So now what I do here is I go in and I just type a name, and I'll type Aston as the name. Now I have the Aston Wireshark trace saved, right? So now what I want to do is look into my packet capture and isolate or make my capture more granular. This is always important to do because you can take subsections of the capture and then use them for either network forensics, as we talked about, intrusion analysis, or a number of other things. So now I come down here, and once again, I'm looking for my DNS traffic. And as we get down here, we got a lot of data, and we'll show you in the next section a quicker way of doing this, but for now we'll do it the old-fashioned way. Scroll through the data till we find our DNS and the Aston Martin packet. So you see, once again, we have a lot of network traffic on this network. A lot of Google, everybody phoning home, DoubleClick, Akamai, pretty much everything you can think about is on this network. Lots of noise. Now that I've saved it, I just want to scroll down and find my Aston Martin packet. And there's a lot of data and noise, so I want to get down here a ways to find that packet. There's different ways to do this, and we'll give a better process of doing this later. For now, we're just doing it the old-fashioned way. So I get down in here, I'm starting to see a lot of solicitation for network traffic, which usually means I'm close to a request, and there's all that ARP request. And now I go on to 2409, right there it is. There's my DNS query for Aston Martin. So after the query, we see here my send packets, right? Different types of things. There's the response. And that looks like the actual traffic for the Aston Martin, but let's find out. So packet number 2417 here on the display. So if I right click, following our process and methodology, TCP stream. Now we have the information from before. So we have the server responding that it's astonmartin.com. And we see here in this case, the server is Microsoft IIS 8.0. And that's the main thing we wanted to do, is discover that what version of the server is being used. In this case, we see what that is. Now, the power of the save capability is we have this capability to save this. So now I can save this component of, just called Aston Web. So now I have in this Aston Web the actual packets that are related to the information leakage of the Aston Martin web server. And that was the goal there, to show you how to do that. So now what you can do is, once you take your live packet captures, you can start extracting information out of them and saving these sections of that information to use, as I said, in an intrusion analysis and using different types of things, or you can actually use them to train, which is very powerful as well. So now you have this capability to exercise the process and methodology using the tool Wireshark. Next up, we're going to continue learning more about the capture methods of Wireshark. More importantly, we're going to look at some advanced methods of how to make this process even easier. In this section, we will review some of the advanced capture methods in Wireshark. We're going to look at importing and exporting data from the tool. We will learn the merge capabilities of the tool. Then we'll briefly discuss using hexadecimal files as input to Wireshark. First, we want to look at merging. We have a powerful feature in Wireshark where we can merge packet captures. This allows us to create detailed and excellent captures to use for our training and our practice. An example of this is, I can capture traffic for a number of hours, then when I analyze it, take the components that contain the important information that I want, and then I can merge these into one complete training capture. That is, I can take hours and hours of captures and only extract the pertinent information I want to be able to do training. That's a powerful feature because we know, based on what we saw already so far in the course, there's a lot of noise on my network. Therefore, since there's a lot of noise on my network, I want to have the capability to extract the important information and the things I need from the network and only analyze that. And more importantly, use it for my training practices. We have the capability within Wireshark to actually do an advanced feature called hexadecimal input. We have the ability to take packet captures that are in a hexadecimal format. That is, if I take output from another tool and put it in a text file, and the tool actually outputs in hex, I can import that tool's output into Wireshark. A lot of the tools that take raw data and output that into hexadecimal, I can input now into Wireshark and read it with the graphical interface that we've been using. Remember, the binary is hard to read. The hexadecimal makes it easier to read. So in this section, we've discussed the merging capability of Wireshark. It has the capability to merge different types of files. So we can take multiple PCAP files and merge them into one training file or to one case file if you want to look at it from a network forensic standpoint. We also explored and discussed the hex format. In the hex format option, I can input a file that's in hex as long as it's in text, and that text file can be input, and then I can display it in Wireshark. Another powerful capability with the Wireshark tool. Next, we'll explore this and merge two capture files using our Wireshark tool. This will give us the capability to build powerful packet captures to add to our library. And we can pretty much do anything we want from a training standpoint. Or if we're doing investigation of intrusion, we can create a packet capture file that has the information that's related to the intrusion, and that can be submitted as evidence of the intrusion without having all that extra packet information in there, which is very powerful. So once again, we want to actually start a packet capture. So go Capture Options, select my internet connected interface, my wireless network connection, and start the capture. Now what I need is some traffic. So now I'll switch over and do Google Chrome since I've been using Firefox. And again, I just go to the Udemy website, will be the first one. So there's that. I go to the Ford website. I go to the Jaguar website. And finally, I go to Aston Martin. I won't go to Maserati on this example. Okay, so now I come back to my packet capture file. And I've got a couple of options. I'll do the first one is merge this whole thing. So I'll go Capture, Stop. Once I stop it, I want to save this capture file. So I click on File, Save. And we'll call this the website traffic. And we save it. Now, all we have to do is click on File, and I want to merge. So I click on File, and I select Merge. And now I just go File, find my file, down here, my website traffic, and I click Open. So now that I have saved it, and I've got my website traffic, I click on File, Merge. And what we'll do is we'll merge it with File 1. So we click on File 1. And now what we've done is we've merged the file with File 1. So if we scroll down here, now we have all the File 1 content as well as the browser content we just created. So now what we would do is save this, and it creates a temporary file, so we'll just save it to our desktop here, and we'll call it File 1 and Websites merged, and we save it. Now the one downside is we have all this ARP traffic that we said we kind of didn't really want to see all that. So one way around this is, as we said, I can create sections of the file. So what I do is I look through this and I find a section using the process that we've discussed so far, and I determine what section I want to keep of the file, right? So different types of things. So I'll only go through one of these because the process is the same. Process doesn't change. Once you've used it, you get to use this same process over and over again. That's the best thing about having a network protocol analysis process. So I got a lot of different things down here, and I'll just pick one so I can show the process. So I got this TCP communication, all right? So as we've added more and more into this, now it has more data. We have more of that ARP traffic. Now, we'll use advanced techniques to help us work with this coming up. For now, we're going to find our query. There's our query of udemy.com. Once we have that, there's our three-way handshake. So what we're going to do is, taking the process we've been using so far, we right-click it, follow TCP stream. This is the actual Udemy information for that packet. So now what we do is, it's a 301, but again, we're teaching the process, so we're not too worried about what's taking place here. And then we just close it, and we save this section. So now we save this section on the desktop's fine, udemy-https. And now we have that portion of the section. So the other one we had after Udemy is we started to do the cars. And we'll do this last one and then we'll continue on. So we just keep scrolling down here because remember Udemy is using HTTPS, so we're not going to be able to read the data there. We got all our HTTPS traffic, so we'll get past all that encrypted traffic and look for some traffic that's not encrypted. There's just a lot of data on the network, and yours will be the same. So this is why we gave you the static packet capture files to practice with. As we come down here, we see Jaguar. Right after the DNS query, we got the DNS response, and there's the three-way handshake for TCP. Using our methodology, we right-click it, and we follow TCP stream. And now we got the information that the Jaguar. So now to keep the Jaguar information, we just go File, Save As, and now we just name the file Jaguar. And if you noticed, Akamai Ghost is responding. So I'll show you that now. So if we look here, there we have the actual blue, the Jaguar web server saying Akamai Ghost. So it's being forwarded from Akamai Ghost. If we come down here, you can see it's really an Apache Coyote 1.1 web server. Again, as we build our skill sets and we learn more of how to do this and practice our process and methodology, this will become very easy to do. So next up, we will continue with the methods of using Wireshark for analysis of network traffic. Now we're going to get into exploring the powerful concepts of filtering within the tool. As you've noticed, I've used the old school way of scrolling up and down looking through the packets. We will teach you a much more proficient and powerful way coming up soon. In this section, we will review the filtering capabilities of Wireshark. Remember when we looked at the packet analysis, we had to scroll down and look at different things in the packet capture. What we're going to do now is add an essential skill, and that skill is applying filters. Learn how to build the different types of filters within Wireshark. So we will explore the usage of filters in the tool. Following this, we'll identify the different types of filters we have available within the Wireshark tool. To effectively analyze traffic, there's powerful filters that we have in Wireshark. This capability provides an exceptional method for us to analyze the packet captures once we have them. As you build your skills, the more you work with the filters, the more expert at analysis you will become. We have different types of filters within Wireshark. With a capture filter, we can control what packets are captured. By setting capture filters, we can build a filter that looks for specific types of attacks. And then if we receive any traffic on that monitor segment, we can have evidence of a potential intrusion. You do not have to have other software. You can do this within the Wireshark tool once you've enhanced your knowledge and your skill. Our other type of filter is the display filter. And as the name states, we use this to control the packets that's displayed on the screen. This is excellent for paring down the information to specifically look for a protocol, specifically look for an IP address, or specifically look for some form of a stream. As you remember, when we did stream analysis, we actually have streams, which is the entire conversation. So by using filters, we can filter out just that conversation that we would like to use. And using the skill we learned earlier, you can save that conversation into a PCAP file and then have it for further analysis, training, or whatever you may deem necessary. In this section, we've explored the filters within Wireshark. We have examined the types of filters that are available within the Wireshark tool. So now that we've done this, we're ready to explore the powerful capability of filters in Wireshark. So next up, we'll deploy filters and examine the assistance this provides us with our protocol analysis. In this section, we're going to return to our file 2 capture file. And within this tool now, we're going to take and use this powerful capability of Wireshark display the packets with a filter. So once you open Wireshark, you can open your file to .pcap.ng file, as I have here on my screen, and you can walk through the exercise together with me. So once you've opened it, the first thing we want to do is explore the actual filter. And right here is where you see apply an actual filter. So what we can do is just enter here ARP, which is our ARP, and then we come over here and we click this blue arrow. Now what it does is took all the packets that were in this packet capture file, and what it did is it only extracted the information of the filter. So if you look at the ARP here, you can see we just have the ARP packets display. And when you look, we've got again the ARP request, who has, in this case, the IP address 6.6.6.7, tell me 6.6.6.6. So then the response is 6.6.6.7 is at 54EE754591A7. Remember, that's how the data gets delivered. So once that MAC or physical address gets received by the requester, in this case, the first packet number 1, then the data can be delivered. So that's kind of how now we can take this complex file, or any file for that matter, once you understand the process, we can take that complex file and we literally can analyze it. So now we clear the filter just by clicking the X. All right. Now remember, we said there's different types of filters. So if we do ICMP and we hit the arrow and we apply it, now we see just the ICMP traffic. So now you can start to see with the skills we've developed and now adding in this capability with filters, now we can take complex protocols or packets that we've analyzed and break them down to a more granular form so we can do analysis to determine what's taking place on the network, be it our network or a network that we're hired to investigate. Now, the next thing we can do is any protocol can be entered here. TCP can be entered here. And we apply. And now we have our TCP traffic. So now what we have is we have that TCP. And if we look here at packet number 17, we have the three-way handshake start. We have a packet going to port 21, which is the file transfer protocol server. And from that, we have a response, which is the acknowledgement of the SYN that we sent. And then the second step in packet 18 also sends a SYN to open the other side of the connection. Remember, TCP is full duplex, so it requires 3 steps or a three-way handshake to open a connection. If you look here in packet number 20, we've identified that we're connecting to an FTP server version 2.0, a 3C daemon. And this is actually a vulnerable version of an FTP server. But again, that's understanding as you get more and more knowledge and experience. All right. So now that we've defined this type of filter, so now we just go capture options. Now, when we do our capture options, you see down here where it says capture filter for selected interface. Now we click on our drop down arrow, and in this case, UDP port 53. So now what we're doing is we're going to look at UDP port 53. So we start our network traffic, and now we need to go to our browser of choice. I will go once again to Firefox. Now when we return to our capture, we only see the capture filter traffic. In this case, DNS. That's the power of the filters. So nothing displays until it matches the capture filter. Now what we have is only those packets that we set in the capture filter. Now, one of the downsides of this is there's no other packets. This is the only packets that we have saved. So if something else was there, we would miss it. All right, so we can only analyze what the capture filter matches. That's something that could be used in segments where you should never see a certain protocol. Say you have a network segment where you know you should never see FTP. So you do a capture filter of FTP. if there's ever anything in the actual packet display that could be evidence of a compromise, because you never should see that protocol FTP ever in your network trace, and that's powerful. Next up, we'll explore the characteristics of some normal and abnormal traffic. You will see how an attacker, when they attack, you will see what it looks like at the network level. In this module, we will examine protocol communication to include normal and abnormal traffic. So what we're going to do is we're going to cover the following: exploring the IP header and analyzing network connections. What happens when we connect and send data back and forth in a network? So when we look here, we have the IP header as it appears in the middle and bottom window of the Wireshark tool. As it shows, these are the components of the IP header, and the encapsulated protocol is TCP. We know the encapsulated protocol because of the type field from within the IP header. This is located at the 9th byte offset. That is, if you count from the start of the IP header with the count of 0, because this is computers, and computers always start at 0, and count 9 steps, the decimal 6 indicates the protocol type of TCP. As we've discussed before, we have the ICMP protocol type is 1, UDP protocol type is decimal 17, hexadecimal 11, and TCP is 6. So we're not going to spend too much time on this because we've covered this, but this is a slide for your review. What we have here, as we said, ICMP is a 1, TCP is a 6, and UDP is a 17, but we can't represent 17 in hexadecimal, so we represent it with an 11. And again, that's the 9th byte offset of the packet header when you start counting from the 4 and the 5, the 45. With TCP, we have guarantee of reliability, and we get this from the control bits or flags of communication. It's connection oriented, as we said. The connection is interpreted as a stream, and that means it's interpreted by the application and not TCP. That's very powerful. That's why when we do that follow the stream, we have the entire sequence of the connection. Now, as we look at the diagram, the key here is the flags. In this packet, the ACK flag is set, as you see here. This means that a packet has been received and it's acknowledging that packet. These flags all have a specific meaning within the connection, and is what we want to understand when it comes to hacking, security, and also intrusion analysis. The flags are as follows. U is for urgent. That means the urgent pointer is set and this data is urgent. A is for acknowledgement, or ACK, which we've already discussed. We're acknowledging something that was sent. Push has data within the packet. Reset, abnormal close of a connection. SYN is open a connection with me. Some like to refer to that as the hello. And then finally, finish is the normal close of a connection. These are the 6 main flags of TCP. By understanding these flags, you can identify what's taking place in the network, both from a standpoint of normal traffic and abnormal traffic. This slide shows the connection for each TCP communication, and that is what we call the three-way handshake. And this is shown here both in the diagram and also in the image from the packet capture in Wireshark. It's a SYN ACK followed by an ACK. Now remember, the first SYN or synchronize says open a connection with me. The acknowledgement is acknowledging that open a connection request. The second step SYN is from the receiver, because the receiver has to open up their own side of the connection. This is why TCP is full duplex and either side can send or receive at the same time. And the final act is the acknowledgement of the synchronize or the connection request received from the receiver. TCP connection close. Remember, we had 3 steps to open the connection. It takes 4 steps to close the connection. This is because we have to close each side of the connection. So here we have in the diagram a FINAC, which means please acknowledge my finish request. And then the acknowledgement returned means I acknowledge your finish request. And the FIN-ACK again is the close of the other side of the connection. So remember, both sides of the connection have to close. This is so one side can close while another side still has data to send. Very important that we allow both sides to send their complete data. One side might be sending 1,000 bytes, for instance, and the other side sending 100. So it's not really good engineering design to require the person with the 100 bytes to leave their connection open until the 1,000 bytes are transferred. And that's why each side can close its own connection. So as you look here in the image taken from Wireshark, we see a SYN-ACK, and an ACK in packet 18, 21, and 22. And then immediately we close 23 through 26. So that's the three-way handshake followed by the four-step close. Now we got TCP connection reset. When something goes wrong within TCP, a reset is used to tear down a connection. If you're seeing a large number of resets on the network, this could be an indication something's not right on the network. In most cases, it is something not right on the network because it's an abnormal close. It's an actual example you see when somebody's trying to connect to a service that's not there. If they keep trying to connect to it, TCP will respond with a reset. You'll see an abnormal amount of resets in the actual packet capture. It's all in the packet. So as you look at this image, you can see the flags that the packet has set. So what is wrong here? This packet has the following flags that are set: the FIN, the push, and the urgent. So the FIN is a finish or a close of a connection, push is data, and urgent is the urgent pointer set. So let's think of this logically. With our analysis, we know FIN is a normal close and push is data, and urgent is the urgent pointer set. Do you think it would be normal to send data in the same packet that is closing a connection? Remember, when we close the connection, we're just telling the receiving side we want to close. We send a FIN flag with the ACK flag set. All we showed you in the slide was the FIN and the ACK flag set. So what about having data or the push flag set in a closed packet? Hopefully you're thinking this is not normal. It is not normal. That's good. This is an abnormal packet. In fact, it's a crafted packet. And since it's a crafted packet, it's an abnormal packet on the network. It's actually the signature of one of the most popular hacking tools that is free and open source on the market, created by a guy that goes by the name of Fyodor, and that is Nmap. And this is what we call the Xmas scan of Nmap. So in Nmap, it actually sets three flags: the FIN, the push, and the urgent. So now looking at this packet, we know somebody is conducting an Xmas scan against wherever this packet is directed. That's the power of understanding what's normal and abnormal on our network. So in this section, we explored the IP header and how to identify the encapsulated protocol. We reviewed the network connections and, more importantly, the communication control bits or flags of TCP. Now you have enough knowledge and enough skill to review abnormal traffic data and some basic attacks using Wireshark. So next up, we're going to take those skills and we're going to apply them and analyze attack communications. In this section, we're going to review the file3.pcap.ng. So if you haven't opened Wireshark already, please do, and open the file3.pcap.ng capture file, and you can follow along, or you can watch me and then work on it after you see me do it. So once you open the file, we want to see what's contained within. Now we can deploy a number of methods of doing this. As we see, there's 24,625 packets in this packet capture. We see here in packet 1, we have an ARP reply. And then we see in packet number 2, we have another ARP reply. The problem is, take a look at packet 1 and packet 2. Do you see anything strange? They have the same MAC address, but they have different IP addresses. That cannot happen. And even the Wireshark tool, the newer version, will show you this, as you see right here, with duplicate use of this IP address detected. So now, what is this? This is two machines on the network having the same MAC or physical address. So when you think about that, where's the data going to go? Is it going to go to the first MAC address machine or the other machine? And the problem is it's not defined because this is a duplicate MAC address on the network. And in this case, this MAC address that's pointing to these two machines is an attacker. And what they're doing is they're setting up a technique called ARP spoofing or ARP poisoning. And what they're doing is they're pretending to be both of these machines. And that is the characteristic of a man-in-the-middle attack. And that's exactly what this is. This is an attack or a man-in-the-middle attack against these two machines. After the man-in-the-middle attack, we can see there are a lot of resets in the packet capture. So as you scroll down in the packet capture, you see a lot of resets. See these resets and then resets? More and more resets. Now, you're seeing a lot of send packets followed by resets. Now, if you remember, we specifically stated that resets are an abnormal close. That means something's taking place on the network. There's concern, so we shouldn't see a lot of these resets. Remember, resets are an indication of ports that are closed. So an attacker, if they go look for ports being open, any port that's closed is going to respond with a reset. So because of this, this looks like indications of what we call a port scan. A port scan is, again, that attacker connecting to as many ports as they can to see if they get a response. The response they're looking for is a SYN-ACK, because the SYN-ACK will do what? The SYN-ACK identifies the ports open. Remember, no matter how good a hacker is, they have to have the port open or a door into the machine to attack it. All right? So we see a lot of port scanning going on. Reality is that port scanning is quite common. From our analysis point of view, we're concerned with the data. So as you may recall from the slides, we have the push flag that represents data. Now remember our power of filter. So now we can actually put this power of filtering to good use and apply it to make this packet capture easier to disseminate and easier to analyze. So now what we're going to do is we're going to enter a filter, tcp.flags.push equals 1. So what that says is if the push flag is set, display the packet. So now all we do is click the blue arrow and we apply our filter. These are the only packets with data in them. And you see here this packet, fin, push, and urgent. You remember what that is? That fin, push, and urgent is that signature that we showed you in the slide of an Xmas scan using the Nmap tool. So now we've got indications of an Xmas scan. Not a big revelation. So an Xmas scan is just a type of port scanning. So now if we go to packet 10295 right here, we see over here in the info section that a version of bind was returned. Well, what is bind? Bind is Berkeley Internet Name Domain. It's what does that DNS or domain name server for the internet. And as you remember, DNS was how we mapped the name to a machine from a human readable form to a machine readable form. So now using our techniques we used, if we right click this, we'll click follow, TCP stream. Right there tells us in blue the server responded with its bind or Berkeley Internet Name Domain version of DNS mask 2.39. So now the attacker has determined that in this packet capture, this target has DNS mask 2.39 that's operating as its domain name server. So that's a concern. So if we clear that filter, close out, and we go back to our other filter, so we can click on our drop down. We go back to our data filter. The wonderful power of filtering in Wireshark, again, is looking at the data. Now, we just followed the string, but you can also see down in here, this is the version.bind down here. So what we can do is we can just arrow down. As I said, everybody has different preferences. But as you see here, now I see this DNS mask -2.39. And I go down and I look at push. Remember, this is all data that's been received. Now this push is HTTP type traffic because it has this GET request here, as you see in the data window. So this goes to a web server. So let's see if anything has been uncovered by the attacker. And in this case, we do have an Apache 1.3.37 running on Unix. It's using mod secure sockets layer 2.8.28 open secure sockets layer 0.9.AE. Guess what? That is leaking too much information. And in fact, all that information that's leaked right there could lead to potential attack vectors for an attacker. So just by following the process that we've covered throughout the course, you've now identified a weak area and an area that could be attacked for either your own network or any network you're hired to monitor or take a look at. That's the power of understanding protocol analysis with Wireshark. You have the tools now. Now you know how to do a number of different types of protocol analysis, and we're going to build this skills in the final section. Next up, we will explore another capture file. You'll review more types of attacks using the process we've enhanced throughout the course. This is to give you your skills and now apply those skills so you get more experience. By learning what we've shown you so far, you can apply those skills and do a multitude of things as we've already discussed. And that's what we're going to do next. In this section, we're going to review the file 4.pcap ng capture file. And I've got it open here in my Wireshark. So like we've done before, if you want to open it up and follow along, you can. And we're going to use the skills we've developed throughout the course to determine what has taken place on the network where this packet capture was taken. So once the file opens, you want to see what's contained within. We have the process we discussed in the previous capture file. So what we want to do is follow that same process. So as we start looking at this packet capture file, we see something interesting here in packet number 4. So in packet number 4, we have MBSS is the protocol. It's net bias session service, as you can see down here in the middle window. So what that means is this is NetBIOS, which is a local area network protocol used by Windows for communications of names. So as you see in this packet number 4, we have 2 host names in this capture file that we can add to our list of things to track. We have one host that's called Vulcan_2, and we have another host that's called external DMZ. Again, these are 2 hosts that are going to be found within this packet capture because they're talking on a Windows network using the local area network protocol NetBIOS session service. So right away we have this information because this protocol MBSS was designed for local area networks and it leaks information. So now we've got leaked information of 2 host machines on the network. So as a matter of a process, we can apply the following method. We know we don't care that much about things that respond as closed or not available. What we want to do is we want to discover what is available. So when we look at a packet capture like this, we want to find the open ports. So we can discover the open ports with a filter. So if we go back to our filter capability here, if we put in tcp.flags.syn equals 1 and tcp.flags.ack equals 1. This tells us give me all the packets with the syn flag and the ack flag set. So only the packets that responded to a request. Therefore, the packet found an open port. And that's what we're trying to do. From our perspective, we're only concerned with the ports that are open. As I've said, an attacker cannot attack something that's closed. All right? So now we have the packets that responded from the connection. As we start looking at this, we have the ports. So as you see here in the info section, it shows every port that was open because it responded with a SYN-ACK. So the left number is the open port. So now we know we got port 80, we got port 4328. So we've got ports of interest, okay? Now, the next thing we want to do is look at data. Remember, our key is to find the open ports and then look for data, because once a hacker or an attacker finds an open port, they're going to try to extract some information. Our job is to figure out what they extracted. So now I just changed my filter to tcp.flags.push equals 1. And I apply. This is all the data within this packet capture. So we had 2,184 total packets, and now we've reduced it down to 819. So only 37% of this packet capture file has data. That's why filtering and applying filters is so powerful. The next step in the process, we want to look for anything that's suspicious. And by suspicious, we mean, if you remember, we had the duplicate addresses. That was suspicious. But we also could have signs of a compromise. When an attacker singles out and attacks something, it's trying to get access. So to look for signs of a compromise, we're looking for things that might have access. So if we look at our packet trace here, and we go down here to packet 59. So packet 59 is interesting, because if you look in the data portion here in the bottom window, there is what appears to be FTP data. But if you look here in the middle window or even the top window, the connection is port 80. If we have FTP, file transfer protocol, the normal port of communication is port 21 for FTP. So this is indeed suspicious. So what we want to do now is we want to investigate further, because what we have here, we have somebody connecting from this IP address at the 223 subnet into a web server, but they're talking to it with FTP. Definitely suspicious. So if I click on it, using our process we've continued to apply throughout, click on follow, TCP stream. Now when I look at it, I see, yeah, it's definitely a Microsoft FTP service, and somebody logged in with user anonymous, and they were access allowed, so anonymous access allowed. That means anonymous was allowed on this server, and they transferred a file. But the suspicious thing is, why is this coming over FTP, coming over port 80 or HTTP? So now we know that we've got traffic over port 80, and that's not normal. Not FTP traffic over port 80. But in this stream, this is where it stops. So if we apply our data filter again and continue with our process, we're still looking to find information of what's taken place. In this case, they transferred a file, but that stream terminates, and we don't have any additional information. So what we're going to do is we're going to perform analysis of virtually any packet capture to determine what has taken place using this same process. We looked for the open ports. We looked for the data. Remember our two filters we've shown. And then we look for suspicious. So we found suspicious here starting at packet 59 because we had connection to port 80, but using the FTP protocol. And that's definitely suspicious. So now when we go back here, we clear our existing filter, and we select our push filter. And remember, we were at packet 59. So now we just continue down. So now, if we go down here further, once we get our data filter set and hit apply, we've got here packet number 102. So once again, we have data that is going to port 80, which was the initial thing. We saw they used the anonymous user login. Once they connected, they transferred some things and then left. But now look, we have FTP here, again, down in the bottom window. We can see we have an FTP server, and we have this FTP traffic coming on port 80. So again, this is suspicious. So what do? All we have to do once again is we right click, follow TCP stream. Now we've got some interesting things. Remember, blue is the actual, in this case, the client sending the information because the server is responding. So when you look at the response, what do we have? Well, we had the anonymous user in our one before, and now we have the FTP user. But more suspicious is this thing here, right here, this bin sh1. Now, if you don't know what that is, it's a bin shell. So they're trying to get a shell on the server using a vulnerability in the software that's running this service. As we scroll down, we see these site exec calls. Site exec is what's actually shown in this FTP version to execute information and data. And it's being passed this AAABCD. But then it's got these things called %Fs, F%, all that type of stuff. What is that? Well, if you're familiar with the programming language of C, this is the signature of an attack. It's what we call a format string attack, because format strings are what identifies to the C language what type of format the data is going to be composed of. So that's what we have. So now all these site execs are trying to get control of the machine and get access. So as we scroll down here, what we're doing is we're looking for signs of a compromise. So far, nothing's been compromised because we continue to see all this data going in. But remember from where our password was entered, we've seen that string bin sh. So they are trying to get with that bin sh a shell. So as we start going down here, now we've got some data. So now what happens is something's changed. The address is changed. Now it's got access to what we call our shell code. Now when we run shell code, what we're trying to do is take control of the application and run a shell. And again, these are things you'll learn as you build your skills, and we continue on. As I get down here, I've got a response. And it's a Linux localhost, local domain. As you start looking down there, you see right here, UID equals 0. So what we have is, this shows us that a shell was returned to the attacker, and not only a shell, but root level access as well. That's indicated here in the UID equals 0. This machine has been compromised. And in this stream, they stopped once the compromise was successful, as indicated here in red. So all they did was get the shell, execute here in blue the ls command, and then they executed the quit and realized that they were in the wrong type of shell, and they executed exit. Once they executed the exit command, they terminated their attack. So now in our analysis process, we figured out there definitely was an attack here. There was a compromise of this machine. So if we close down this stream, we'll look at one more. So if we go to packet 1211 in the trace, so we'll do a little technique, go to packet, and we enter 1211, and we click on go to packet. Now we've got the same type of thing, port 80, and we're looking to see if the attempt of the attack was successful. So using our process that we've perfected throughout, right click, follow TCP stream. In that case, you've got scripts %C0 %AF, that's a / in Unicode, and the attack wasn't successful, but they uncovered, in this case, a very old version of Microsoft's IIS server 5.0. So that would be a concern. So if, say, let's use a scenario. You were looking at this for a client. You would go back to the client and say, this machine, indicated here with the Microsoft IIS 5.0, is at a high risk of being compromised. Then you would look at the network diagram with the client and see what segment is this machine on and what can we do to protect it. We can't just go in and say update to a new server. We don't know why that machine's running Microsoft IIS 5. So as you get more skills and knowledge and experience, you help the client mitigate their risk. And that's our job as a professional security tester, which right now we're building your foundational skills. So since it didn't respond with a 200 OK, this wasn't successful. So let's see if we can find a successful one. So now we're going to go to packet 1495. So now if I go to packet 1495, using my same go-to packet technique, same thing, port 80 traffic. Oh, this is 4463 traffic. So here I am at packet 1495. If I right-click that follow, TCP stream. Now we have a little bit different. Remember before we got a 500 error and nothing happened. Now this packet has returned that this machine that's running that Microsoft IIS 5 box is actually a Microsoft Windows 2000. And not only that, it returned a shell to the attacker. We see this is indeed a compromised machine. So now we would go to the client and tell them this machine located here has been compromised. And then we would help them identify what their policy is after an incident and help them do their incident response plan. Now, all we see so far is in this packet capture, the one we're looking at here, all they did was compromise it, get the shell, verify that they had the shell. Microsoft Windows 2000 was the version, and they hit exit. So in this trace, yes, the incident report would say the machine was compromised, running a very old version of IIS. We've seen that %C0, %AF. As you build your skills, you get more knowledge, you'll understand that's what we call directory traversal attack, something that this version of IIS and a lot of other versions of IIS are very vulnerable with. So now this is what we want you to understand. Now that you have this process, you've built your skills, you've built your foundation, the more you practice, the more you can identify how to analyze network traffic using protocol analysis, using the Wireshark tool, which makes it much easier by using filters. And this concludes pretty much the course. Next up, we'll close out the course. But now you have the skills and the foundation to do protocol analysis in Wireshark. It's an exciting world. Have fun with it. This is an example of one of the bonus files that I've created. So what we want to do is we want you to take the process you've learned in the class, and once you take that process, apply it. So if you remember, one of the first steps of our process was look for suspicious traffic, and the second step was looking for open ports. So as a reminder, you just do tcp.flags.sin equals 1 and tcp.flags.ack equals 1. So what that says is give me all the packets with the SYN flag and the ACK flag set. That's the second step of the three-way handshake. So when we send a SYN, we get back a SYN ACK. So when I apply this filter, now these are all the packets with the SYN and the ACK flag set. So the next step would look for data. And with the data, it's the push flag. So what we want you to do is we want you to go through these bonus files. This is the first one, there'll be more, and see if you can analyze what's taking place in the trace. Also, if you find anything suspicious in the trace, annotate that. If you find signs of a compromise, annotate that. Send a message in the forum to me of what you think the actual trace has in it, and then I will post a solutions file or even do a solutions video depending on how many we get once I get a minimum of 10. Once I get a minimum of 10 people that have participated in the actual challenge to look and figure out and analyze these files using the process we've discovered and shown you in the course, then I'll post a solutions file and a video for that. Once that's done, then I'll add more additional content as well. So I'll have several of these, but this is the first one. So what you want to do is you want to apply the process that we've talked about in the course and then analyze what's taken place in this packet capture file to practice. The best way to do protocol analysis is to practice and enhance and hone your skills. Have fun and good luck. The first thing we want to do is follow our process. As a reminder, that is, look for suspicious traffic, identify open ports, look for data within the packets, analyze the streams of data, look for signs of compromise, draft a report of your findings. So one subtle thing when we start looking for our suspicious traffic, one of the things you might not have missed, or you might have missed, I'm not sure because I didn't have anybody mention it in their analysis, is take a look at these IP addresses. These IP addresses in here, do they look right to you? Even the Wireshark tool is giving you red saying something suspicious here. What is that IP address? It's the 224 address. That's actually multicast, and that means that the address should be used when you have bursty or not steady traffic. An example of this is we use a multicast with radar data. The one thing to take away from this is the fact that this type of address should never make it in from the perimeter. So you could tell the network team that they're not doing proper ingress filtering. That is, they're allowing inbound traffic that should never be received from the perimeter to get into your network. Not a good thing. So none of this traffic should make it into our networks. Since it has, we will continue with our process. The next step we want to perform is look for open ports. That is, set our filter tcp.flags.send equals 1 and tcp.flags.ack equals 1. We'll go ahead and forego that step because it's just a simple step to do. And we'll look at the next step of our process, which is look for data within the packets. That is the flag tcp.flags.push equals 1, and we hit enter. All these packets have data within the packets. All right. So the process now is to look for streams of data. So we've got a lot of HTTP traffic, and we'll look at that momentarily because we've got some different things we'll look at for that. And as I told you before, I just scroll through the bottom window. So you can pull this up here and then pull this up, and then you can start scrolling through the bottom window down here to look at the information. And it's interesting that we got the NSA, but we'll talk about that more later. Most of the responses that you receive, right, they've got these 404 object not found. That means this query never was responded to by the server other than to say it wasn't found. So that's data, but it's not a threat to anybody who's doing analysis of an intrusion, those types of things. So if we go down here and we look at this packet down in here, we got these push packets here. So if we right click this, and we'll follow TCP stream, of interest right here is this metasploit.exe. Okay, so that's Metasploit, which is a well-known hacking tool, and of course that would be a concern. And as we come down here, we see FTP. This is some FTP information. So what we've got so far is we've got suspicious because we got a metasploit.exe file and we have FTP information in the trace, but nothing of a major attack looking platform yet because we got to do more investigation. So it's definitely a file transfer, and we got metasploit.exe. Now if we go over here and we clear this and we take a look here at packet 295 and we follow this TCP stream, now we've got a lot of data that comes in, and now here we have connected to a Meterpreter server. For those of you know a little bit about Metasploit, that means the Meterpreter shell has been opened on Metasploit. So this is definitely a concern because somebody has compromised one of our machines. But again, the biggest concern is this 224 traffic, which is multicast, is being allowed from the internet. That's a big problem. Okay, so now let's look at another one. If we go to packet 556, and remember, that will be the start of the handshake, and the data is just below that. So in this case, the push right here. So packet 559 is the push. So we do a follow TCP stream, and now we have actual indications of another shell. So again, we have all these shells in this network trace. That means in this case, this site's been compromised multiple times. Okay, so you get that. So that's the main signs of compromise that we look for. Now the next step would be draft a report of your findings. But there's some more tricks that we want to cover here. Some of you might have done this before and maybe not, because of being a beginning level Wireshark, we didn't really get into it, but I'll get into it now. And what that is Wireshark gives us the capability when we have HTTP. If you see, we got a lot of HTTP traffic here. So if we do a TCP.port equals 80, you see we've got lots of packets. 217 out of these 581 packets, I'm getting this information down here, 217 of these packets are HTTP. Well, Wireshark gives us a great technique and a trick, which is called statistics. So if I click on statistics here, and I go HTTP requests, this will show me all the actual HTTP requests to a web server. Look at these requests to this web server 192.168.1.50. Look at all these actual requests. Script, root.exe, winnt, system32, command.exe. Them are all shell requests to a web server. And now web server should never respond to these. But if a web server responds to traffic, that response is what we call a 200 OK. We have another great feature of Wireshark, and that's the filters, of course, but we have another filter that we can use, frame contains. So if you're looking for a specific file or malware or something like that, you can use the frame contains filter. In this case, we're going to say frame contains 200 OK. When I hit enter, these are the only packets that out of all those queries responded with an OK. So the first one, right, each of these packets represents a request that was accepted. Now we continue our same process and we review the streams. And we see here this packet 58, if we right click follow TCP stream, interesting that it refers NSA, but we see here that this command.exe c plus dir, which is giving me a directory, it's accepted by this old IIS Microsoft 5.0. And not only is it accepted, but it gives me a shell. So now I've got shell access via the web port, port 80, and now I have an indication of this. All right. Now, we know we've got a compromise when we think this refer is fake. But in today's cases, we're not sure the NSA might attack us or not. But again, in this case, I created all these, so it's definitely created by me. Okay. Now, if we go back to our frame contains, and again, you just keep selecting your filters. And then I go here and I right click this packet 89, follow stream. And again, I have a sign of a compromise. So both of these are compromises. So we had all those shells that we've identified already. And we also have all these compromises. So we definitely have a lot of intrusions, not only intrusions, but successful intrusions on this network. So we apply our frame contains, and we go to the next packet, this one at 114, all right? And we right click it. This is another sign of a compromise. So all three of those first ones we looked at were all shells and all compromises. And now we go to this one, this packet 137. Now this one has a head command. So what this is this is manually entered by an attacker, the head command, and says, give me the header from the web server. Now this head command should never be used in a modern day web server. So this HTTP 200 OK means that this was accepted by the web server. So you could go to the administrators of this web server and say, hey, you're not following best practices of security because you just accepted a head request. There's no reason to give a head request because all it's used for is to enumerate the actual version of the web server. All right, let's look at the next one. So when we go to this next one, packet 162, this is the same concept, but it uses the GET request. Again, it's manually put in because there's not all that additional data that you see from a browser. So when you see this GET request, you get another 200 OK, but now since it's a GET request, it returns the entire page. And that's what a GET request does. This happens every time you do a browser and go to a website. A GET query is issued to that web server and it says, give me what's located at document root. Okay, let's look at another one. And this would be the last one we look at here. Follow TCP stream. Now we got the same thing, this winint system32 command.exe, but we get a lot of other data in here until we get what? The 200 OK, and then we get our directory. So that's another compromise. So two of these queries were just information gathering and enumeration, the GET request and the head request. And then a number of these, the winint system32 command.exes, were all compromises. Not only compromises, the 200 OK shows it was successful. So remember, we just look at the streams. So once again, the frame 200 OK, when you have a lot of web traffic, you just put that filter in. Frame contains 200 OK, and then you go through all these and see what took place. So we did this one, we followed a TCP stream, and there it is, sign of a compromise. This pretty much covers everything in this challenge file. If you have any questions, please let me know. Also, I'll have another challenge file posted before the end of the month. Remember, it's all following this process. Look for suspicious traffic, identify open ports, look for data within the packets, analyze the streams of data, look for signs of compromise, and then of course draft a report of your findings if you're doing this in a security operations center or something like that. One last note, I know some of you were wanting the information right away, but it's better to let you work through and try to practice the process. This process doesn't change. What we change is we're going to change the actual network traffic you look at. So each time we do a challenge, you'll get more and more experience and practice at working with that. But if you really need to know, again, just contact me on LinkedIn. I'm easy enough to find on LinkedIn, or post me a message and I can give you help to find me if you can't. But I believe I'm also listed in the profile for Udemy for my LinkedIn. So again, this is the process you want to practice and follow, and use Wireshark to hack networks like a pro. Thanks. This is bonus file 2. So now you're going to have bonus file 2 to deal with. And you see here we got 42,338 packets displayed. And you want to go through the process that we've been talking about and the methodology. And again, the process and the methodology is looking at the traffic and seeing if anything's suspicious. So as I start scrolling through here, I'm seeing a lot of resets. So that's definitely something you might want to take a look at that's suspicious. So I'll do as I've done before, and I'll actually post this and give you some time to try to analyze it and see if you can tell what's taking place. There's a lot of information in here, and follow the process. And I'll post it again when I actually put in the announcement in the class, but it's the same process. You have the suspicious, look for suspicious traffic, look for ports, look for data. Once you find data, start looking at the sessions, looking at the streams, try to determine what's taking place, and enjoy. That's what part of doing protocol analysis is experimenting and getting more information and more practice at different types of network traces. So have fun. So we've covered on numerous occasions, the first step in our process is look at the traffic to see if we can find anything that is suspicious. As you start looking through here, Wireshark's helping you out because it has all these red things over here. That's usually indication of a reset. So we start looking through the traffic, you see there are lots of resets in this traffic. That's not normal. In a normal production network, you're not going to see this many resets. When you see these many resets, it's more than likely somebody's doing something trying to gather information. Because remember, a reset means something's not there. It's an abnormal close of a TCP connection. And when we start looking at this, we want to actually look at it from the approach of our methodology. Remember, the entire time we're learning how to hack and develop and learn these different types of techniques, we want to be able to analyze it at the lowest level. And that's the packets. And that's what I want you to understand. It's all about what's in the packets, not the tool. So you want to be at layer 2, layer 3, those types of things when you're doing your skill enhancement to learn how to do the different types of techniques to either do the hacking side or do the recovery from a hack. Okay, so what do we look at? Well, we look for open ports, and then we look for data, And then we look for sessions. And then we look for streams to see if any of the data has been used in any types of streams that's some type of an attack in most cases. So if you review this, again, there's many reset packets. What we got to do is determine what's causing these resets. Again, it's a probable sign of a port scan, but we put in our filter, our flags.syn equals 1, and our tcp.flags.ack equals 1. So we've got them both, and we apply it. Now remember, these are all the ports that were open because of the response of the SYN and the ACK. That's what we're looking at here. So when you start looking, you can start making your list. 139, of course, the net bias ports. Got some 80 traffic, so we'll look at that. 135, more net bias. 21, so an FTP server. 1025, Microsoft messaging services. 445, more net bias. 1027, 1026, 1433, which is SQL. So there's some SQL traffic in here, right? Those types of things. So we can start going through here and we can look and see it's a repeated pattern. So now we know pretty much that's the only ports that were open that this possible suspect or whatever here it is, because we really don't know yet. But we know something suspicious because we see all these different types of probing. So now if we go into one of these that we've got a SYN-ACK on and we follow the stream and there's nothing there, that means this was a scan. Now we got two types of scans. We have a connect scan, which completes the three-way handshake, and we have a stealth scan or a half-open scan, which doesn't complete the three-way handshake. And when you see this right here, the SYN-ACK, the ACK, and the reset ACK. So this completed the three-way handshake. So this first scan we look at right now in this packet 2111, 2011, shows us that we have a port scan. In fact, we have what's called a connect scan. Okay, so now we clear that filter and we put it and apply it again. And again, what are we looking for? We're looking at the open ports, right? So we got the 1433. That's always a good one to take a look at. So we apply this, follow the stream, and we see once again, this is a query of a probe and a port scan. In this case, it's the half-open scan. So at packet 1503, we have a SYN followed by a SYN-ACK, which of course is the target, and then the reset. Notice how it's a reset and not a reset ACK. The theory was with a stealth scan, it wouldn't be logged by the target. But today, pretty much all your detection monitoring devices know this, and they will detect these types of things. Okay, so now we've done this. So what's the next thing in our methodology? Well, remember, we look for open ports, and the next thing is data. To look at data, we do tcp.flags.push equals 1, and we apply it. This is all packets that have data in them. Now, everybody has different preferences, but my preferences, I've said before, I just use the bottom window, the data window here, and I start looking in this lower window to review the information, see what I want to investigate. And that's kind of how we do it. And we just scroll down, all right? So I won't go through every possible one because we've covered quite a bit of things on this, those types of things. So we've got some good information here, lots of different things, a lot of push, a lot of data. And I start looking through, and there's that version.bind. So now here I've got version.bind telling me that they extracted a bind version on that service. And again, remember, what we're looking for here is what did the potential suspect or attacker uncover with their scanning? Because the way the methodology works for an attacker, the way it works is they go for the live systems. Once they got live systems, they look at ports. Once they got ports, they look at services, what's running on those ports. And then they do enumeration, what's running on those ports, and can I log in and do the other types of things. In this case, we see we got Samba down in here. So again, that's our process. There's one more for you to look at. When you see a packet like this, a GET request packet as we're showing here, all right? So when you see that type of packet, it's manually entered. It's manually entered because that's all you have. Remember, if you're going to be doing this from a browser, you normally would see the actual type of browser and additional metadata here about the actual browser being used. So again, that's a manual probe that extracts the actual banner from a web server. In this case, it didn't have anything on it, which is good. So now we go back to our filter. Now remember, you can save these filters as well, so you don't have to keep doing this over and over again. And I keep looking at different things. So what am I looking for? Again, looking for things that look weird, suspicious. Right here we got Microsoft, some information about Microsoft, those types of things. And the best way to explain it, the OSCP, offline certificate services, those types of things. TLS, we're probably not going to be able to read the data in the TLS because that, of course, is encrypted. So since it's protected encrypted, we probably can't find a whole lot on that. So we're okay here. So we just keep going down. Let's go down here a little ways. And again, it's a process. You just apply this process and you practice, and you keep practicing it over and over again until you get better at what you're doing. All right. So we've seen some FTP traffic. So let's do a TCP.port equals 21. These are all our FT packets in the trace. All right. So we got some down here. And what I usually look for here is I look for the three-way handshake. So you see the SYN, you send the SYN-ACK, and the reset, right? So you're starting to look and seeing, is there any in here in the FTP that goes SYN, SYN-ACK, ACK? So I just scroll down a little bit here anytime I'm doing the analysis or forensics investigation, and I'm looking to see if it's going to change its characteristics. Now, I do have something interested here that I might have to look at later, but I just keep going through and looking at the different things until I see a three-way handshake right here. See this? Goes a SYN, it goes a SYN-ACK, and ACK. There's the banner, the Microsoft FTP server. Now, let's right-click it, follow TCP stream. And now we have the user anonymous was allowed, anonymous access allowed, logged in, enter in passive mode, data connection ready, transfer starting. So now the perpetrator or the suspects uncovered that in this case, this network was allowing anonymous FTP. All right, so that means I can access. The weakness would be, can I do a write? So again, these are the types of things we want to do. So there's a lot of things we can do here. So if I do TCP.flags push again, equals 1, and I apply, I just look at the data. So again, it's just a process of following out a methodology, step-by-step methodology, and looking for data in the packets. All right. Now, one of the things we've always got the capability of is just recognizing immediately when something doesn't look right. In TCP, we have our 6 flags: urgent, ACK, push, reset, SYN, and FIN. Now, it's normal traffic to see certain flags set and abnormal traffic to see flags set that shouldn't be set. So when we go in here and we start looking, we're looking for some abnormal traffic. So what would be abnormal traffic? An open and a close. So a SYN and a FIN in the same packet should never happen. Because remember, the SYN is the first sequence, and you got a SYN and an ACK and those types of things. You never should have this. See how we got a FIN, a SYN. Remember, a FIN is a normal close. A SYN or a synchronize is a normal open. So I've got an open and a close. Also, I've got a data, and I got the urgent pointer set. This is, in fact, here at 12944, this is a crafted packet. So that would be something to investigate to see if the crafted packet got any data back. But this one here is even better. This one at 12987 is actually FIN push and urgent. This is the classic signature of an Xmas scan using the Nmap tool. So we've uncovered all this information. So if you were doing network forensics on this trace, you know this person's doing lots of port scanning. All right, so they're doing port scanning. What do we say after port scanning? We do enumeration. So the data is identified with the enumeration. And then from there, we try to leverage and look for vulnerabilities. And that's kind of what we're trying to do when we're doing our hacking. So everything we've discovered so far shows the suspects using an Nmap tool to gather information from the network. Right here in 13207, if we come down here, we actually get the indication that is in fact Nmap. So if we come down to 13207, right here, how do I get that indication? Nmap scripting engine right there. It tells me it's an Nmap scripting engine. So when you're using an Nmap scripting engine, it's running all these different scripts by default, or depending on the perpetrator or the suspect, they could be running specific ones, right? So we know they're running that, and we've also got some web traffic in here. So one of the things we always want to do is we want to actually look at port 80 traffic. So let's do a TCP.port equals 80. And this is all our port 80 traffic. As you can see, I'm starting to see profind here. This is all Nmap scripting engine stuff. The options command, all this stuff is Nmap scripting engine. And remember, really, the best way to look at the web traffic, I can apply another filter. And that filter is frame contains 200 OK. And now when I apply 200 OK, this is all responded to by the web server. And I just start looking for different types of things. And I said, okay, let's look at this. To follow a TCP stream. This shows me 200 OK, and it tells me the hacking tool Nikto was being used here. Now the nice thing is, they're not deploying any evasion tactics. So whoever this hacker is, either he's running a default NICTO scan, or he's not familiar with the intrusion, the evasions, and all the other stuff it can do. Now, my bigger concern from a security standpoint is right here. Microsoft IIS 6.0. It's not good that I got a Microsoft IIS 6.0 server in this trace, because there's been lots of vulnerabilities in Microsoft IIS 6.0. So again, we now know NICTO is being used. So what we covered in the past was, if I know a web scanner is being used, the best way to look at the web scanner traffic is to click on statistics. And then what I do is I go into HTTP requests, and there they are. And you start seeing, you start looking at some of these requests look kind of strange. That's because it's a scanning tool. In this case, it's NICTO. As you see, NICTO's doing all this cool stuff, right? All these different things it's doing. And as we load, we're loading more and more stuff. HT access, all those types of things. So again, a lot of information being used. As you see, it's still trying to load all the actual tool or traffic, because there's so much data there. And you see stuff that shouldn't be there. PWD, password, HT access. You shouldn't see that in your network traffic. So again, it's understanding what to look for. Okay, so you got the idea of that. Now, we've covered the majority of the actual types of things to look for. So if we go and we go to this packet, I just want to show you one other thing here. 15743. We just keep looking. Again, it's just a matter of looking through the packets and looking for the data. So in this case, I got a script command. This is NICTO using the script command. And I come TCP stream, and this is what you want to see. In this case, unauthorized. So even though they ran the attack, in this case trying to do a script command, it's unauthorized. But the bad side is, we still see Microsoft IIS 6.0, which is not good. So again, these are the types of things you can uncover when you actually look at different types of things. So if we go and we do our tcp.port equal, and what happens is the more you do this, you get used to looking for patterns. Remember, all hackers follow some form of like a methodology. So we look in here and we start seeing some information. Some 1433 traffic, that's all port scan traffic. There's a three-way handshake, so we can take a look at that. Always look for the data. We can do that as well. Microsoft SQL server. So we see it's using a Microsoft SQL server, and we can extract information from that. Now, I've covered the solution here, and I got the index and those types of things. So again, what you want to look for is, where is that IIS box? So let's go look at that again. tcp.port equals 80. Yeah, and let's see, we got the send ACK, so we got three-way handshake, we got the GET request, right? And it looks like in this case, the GET request is going to this 60. So let's see. Yeah, and we got a 200 OK, and we got Microsoft IIS 6. Now, from the standpoint of what we're doing here in our analysis and learning how to hack like a pro, now I know what an attacker is going to do is they're going to extract this information, and that's my vulnerable. So what I want to do is I want to filter just on traffic to and from that machine, because I know it is our weak machine based on what we're seeing here. So now this is all the 160 traffic. So now we start seeing, the 60 traffic, host 60 traffic. So now we start seeing a lot of information going to and from that box. So what do we look for? Well, again, it's that process. It's just the same process we've applied over and over again. We look through here. I just like the lower window. People have different preferences, and we do different things, and we cover a lot of different information and how to do that. Now, I don't want to give away all the secrets, because I want you to actually do some research and figure out some things on your own. So if I go here on this packet and follow the stream, it's a help. All right, so that's interesting. The client tool actually just typed in help. And you go see, and you start seeing you got some data in here, right? Unauthorized, all that type of things, scripts, negotiate, different things. And what was the one I said to look for? Frame contains. So if I do a frame contains 200 OK and IP.addr equals 192.168.177.60. So now I've set a filter that says, give me all the frame contains 200 OK and the IP address. So Now I'll see if I get the data. And now I've got data. And I start looking down here, and now I start seeing more and more information that went to and from that machine. And from here, it's a matter of trying to put all this together and find out what's taking place, right? So there's no real magic key here. It's just basically take and look at a stream and look for the data. In this case, 404 not found. You're saying, well, why is it in there? Because if you keep going down, it's still extracting information. Resource can't be found. All right, as I scroll down, we got, again, Microsoft IIS 6.0. Nikto, this is all the Nikto scan stuff going on. All right, so this is all Nikto, all right, different things. And information, the description. And again, as we keep going down, we've got more and more data to review. Now the trick is, and I showed this before, is when it's a database, start looking for database content. And in some cases, you'll be able to discover what the database content is. But in this case, since it's Nikto, more than likely it's just a Nikto scan. But you've got the idea. And I kind of wanted to give you this type of information now for this packet capture. So now it's on you to actually apply it. Explore more and build your own capture files. Remember, when you do anything related to hacking or any types of incident response, you want to always be able to look at it at the packet level. So start Wireshark, run your different attacks, and then review them in the protocol analyzer at the packet level. This is how you can learn to hack like a pro. And hack like a pro means you understand network attacks. You understand all these different things attackers can do at the packet level. A lot of people think it's running tools. It is not running tools. It's looking at the packets, understanding what the tools do on the network by analyzing those packets, and then you can create your own tool, or better yet, you can create and mimic a tool just by running data that matches that which you discovered in your protocol analysis. And that's how you learn to hack like a pro. Enjoy it and have fun. Thanks. Throughout the course, I've talked about the process. What I want to cover now is the hacking process, and more importantly, the actual scanning methodology. So when you do hacking, you have information gathering. You do like public records, information from public resources. Some of you might have heard of Shodan. You can use the Shodan website, those types of things. But what I want to talk to you about is the actual engagement of the targets. And that's why I tell everybody that in 25 years, the process hasn't changed. What has changed is the targets and the tools we have available. The first step in our scanning methodology is to discover these live systems. And we do it within map with the dash, lowercase s for scan, uppercase P option. Now, if you use ZenMap or another tool, it will actually dash lowercase s and a lowercase n. That's the newer way of doing it. But this way, the dash lowercase s uppercase p works across all versions, just not the new ones. So I kind of prefer that. So what we're going to do now is I'm going to run this scan, and we're going to observe it in Wireshark. I'm in my Windows prompt now. I just do nmap, and I do dash lowercase s uppercase p, and I put in my subnet, which in this case is 192.168.177.0/24. So that's going to go out and look for any live systems on this subnet. And in Wireshark, we'll see that what it's actually doing is address resolution protocol. So it's actually using ARP, and it's using ARP because I'm on the same subnet. If I was going across an actual router or some type of filter device that was a different subnet, then it would use ICMP. And a lot of times ICMP is blocked, so we have to do what's called a TCP ping. So we'll look at this now in Wireshark. One of the first things I want to point out to you is two of these IP addresses, the 192.168.177.1 and the 192.168.177.254. Those are the virtual switch from VMware of the targets that I've got set up. And the 200, the 192.168.177.200 and the 192.168.177.210 are my targets. And that's what we want to do here is we want to identify what our targets are, live systems, because no hacker in the world can hack something if it's off. If it's off, I can't attack it. All right. So now that I know this, I'm going to look at it in Wireshark and then go look at our next step in the process. Let's do that now. So here we are in Wireshark, and a couple ways I can do it. I can filter, or I can scroll down and look for the scan. And there's the scan. And you see it right there. So it's telling me who has, tell me. And he literally, Wireshark does, reports all the ARP broadcasts. So the actual Nmap tool is sending out to broadcast and looking for responses. And it keeps going out until it gets responses. So as we go down here, we see who has, and that's literally what's taking place at the packet level. So if we want to, we can expand the ARP here and look at the information and see exactly what it is. And the opcode is a request. That opcode being a request tells us that that's an ARP request, right? All right, so now what we're looking for is the responses. You see, we've only got the 2 live targets, so a lot of these responses are just requests going out, but there is a reply. So remember the opcode before was a request? As we're seeing there in the Wireshark trace, the opcode's a reply. So now that we have the ARP that went out and came back, we have the 200 as a target, and our other target was 210. And there's 210. So that's our 2 targets. So that's what happens with Nmap. So now when your hacker is going against your network, if they're doing the live system step of their process, when they do that live system step of their process, that means they're going up and they're looking for their actual, yeah, exactly. They're looking for their actual live systems, because I can't attack it if I don't have live systems. And that's the first step in our hacking process. In our first clip, we actually looked at looking for the live systems. So what's the next step in our process? That process step is ports. Now we have 3 different options. Remember, the dash lowercase s is for scan, and we're using the Nmap tool. And the uppercase S means a SYN, or what we call a stealth, or another way of looking at it's a half open scan. And then the dash lowercase s, uppercase T is a connect scan. And the difference is the S scan, stealth scan, SYN scan, or half open scan, whatever you want to call it, is actually not going to complete the 3-way handshake. The T scan will complete the 3-way handshake, and as such, it'll be logged by the target. And the U is for UDP. Now, it's difficult with UDP because UDP has to have a closed port to get back an ICMP type 3, which is destination unreachable. And then why it's unreachable, the port unreachable. So it's an ICMP type 3 code 3. So those are the different types of scans. But as I said, the UDP scan will take a very long time to complete. So we're mainly going to look at the TCP scanning. Let's look at that now. And remember, we have targets now. So the first scan we're going to do is the SYN scan, but we're only going to do it against our targets. We're not going to do it against the whole IP range because that's a waste of our time. And you always don't want to waste time, especially when you're doing an engagement. And almost all your engagements in professional security testing, penetration testing, vulnerability assessment, or whatever, all those engagements are time limited. So you want to make sure you get as much done in the time allotted as possible. So this scan running is going to take a little bit of time to complete. Now what we can do is we can actually go over to Wireshark as the scan is running and take a look at it. So that's an option always as well. So now as you see, there's a lot of ports open on these machines. And there is because I've chosen these machines which are deliberately vulnerable. So the first one, the 200, has SSH, secure shell, HTTP, web traffic. So now what we've done is we've done the live systems. We have 2 targets. We've done the ports. Let's go look at what it looks at in Wireshark. So here we are in Wireshark, and the dead giveaway of a port scan is resets. So you start seeing all these resets, you know you're getting an actual port scan. All right. Now we've seen that the actual port that was open in the list from actual Nmap. But if you remember, we looked at this filter early on in the course, and that's .syn, tcp.flags.syn equals 1, and tcp.flags.ack equals 1. Those 2 flags set together means the port's open. As you see here, we've got open ports here. So we mentioned secure shell specifically. So remember the process. We just highlight it, we right click it, and we follow the TCP stream, right? In this case, you're like, well, why is nothing there? Because it's a port scan. And right there it is. You got the SYN, you got the SYN-ACK. So you've got that, and you have nothing actual that's following that, all right? So this is what you want to look at when you start looking at your different types of network traffic to see what's taking place. Now, a better way to do this scan is to set up a specific filter. So let's do that now. So we'll do a capture restart. Rather than have to go look through it, let's just create one for us. So then what we do is we're going to do tcp.port equals 22, because we know we have a target with secure shell. So tcp.port equals 22, which is SSH, and we apply our filter. As you see right now, we have no traffic to that. So what we're going to do is we're going to go back to the Nmap tool, and we're going to do a scan and see what it looks like when we do both the stealth or the half open scan, and then again when we do the connect scan. So let's look at that now in the actual Nmap scanning tool. So here we are again. We'll clear the screen to make it easier. Now what's the nice thing about Nmap is we just put in the actual scan and we just tell it with a -P option for port what port or ports to look for. In this case, it's just going to look at port 22 for these two targets. And that's all we do. And we run the scan. Remember, it's going to send out a SYN packet if it gets back a SYN-ACK, which it will in the one case where it's open at. And then it's going to send out a reset to tear down the connection, not to complete the three-way handshake. So while that's running, we can switch back over to our Wireshark. So in Wireshark now we see port 210 and 200 both responds with a SYN-ACK. So tcp.port 22, in this case SSH, is definitely open, but we never complete the three-way handshake. All right, so let's go back to the capture, restart, and now let's do the next scan, which is the connect scan. So now we come back here and we just change our S to a T. And now, once again, we just give it time, and then we switch back to Wireshark and we look at the result. So now if we highlight one of these, let's stop our capture, clear the filter, and then look for our tcp.port equals 22, apply it, and now we see here we got the SYN, the SYN-ACK, and then the reset-ACK. So what actual Nmap is doing is it's completing. Remember, you send the SYN. So Nmap sends the synchronize, the first SYN packet to TCP, gets back a SYN-ACK, and then sends the final ACK. So it actually completes the three-way handshake. And that's what we've shown here. Right? So that's the process of how we would actually see this be carried out on our networks. All right, so that's the second step of our process. And for this clip, that's where we'll stop at, and we'll do the third step of the process in the next one. We're keeping these nice and short so they don't take a long time to play, and you can look at them in your leisure time. So let's do that now. Now that we've looked at the live system, so we identified two targets. We have the 200 and the 210 IP address as our targets. We've looked at the ports and we found they have a number of ports open. And that's important to remember because ports are doors or ways that hackers will break into systems. So that gives me a path of access into the system, and that's why we need to now look at the next step, which is services. And in services, we're going to use the same thing, the dash lowercase s uppercase v, but now we're going to return any banner that's connected to the port. As you can imagine, this will take more time because it's going to extract data. And then we'll look at the filter, and you might recall in the actual course that we've progressed through earlier in the course, we showed you how to set the actual filter looking for data. And we'll do that as well. So let's look at this scan as it looks like in Wireshark. So here we are. We're back in our command prompt. Now, we could scan the whole thing, but why don't we just, for simplicity, scan the one port? And while we're looking at that, we'll kick off the scan for all ports. Not all 65,536, because the process is the same. It doesn't change. So once you've looked at it and you understand the process, then you can run it against any ports or even all ports if you would like to. So now the key here is look at what we've got. We've got OpenSSH on one machine, the 200 machine, 5.3 P1, Debian, 3 Ubuntu 4. So we know it's Ubuntu now. It's a Linux Ubuntu, and we've got the protocol. We have all this information just by doing the services scan. So the next step in the process, of course, we're going to leverage this. And this is how professional security testers, hackers, pen testers, this is the process they're going to follow. As I said, this process is the same process I've been following for more than 25 years. So it's nothing new. You just keep working it to work at the different targets, different tools require to use different techniques. So let's take a look at Wireshark and see what it looks like in Wireshark. So now, as I said, the best way to find this is the data. So we can do the flags dot push equals 1 for the data. And there we go. We can right click it and follow the stream if we want to, but as you see there in the info part, we already have the information. So we don't really need to follow the stream unless we wanted to. And that's what it looks like when a hacker is extracting the banner or the services from your machines and or your network. So now we have taken it all the way through to the step where now the hacker's ready to take this data, analyze it, and take it to the next level. And we'll do that in the next section. So in the previous sections, we've done the live systems, we've done the ports, we've done the services, and we saw what they all look like under Wireshark. Now the next step in our process is enumeration. And enumeration is trying to extract all the information we can from the target. Now in Nmap, this is what we call the -A scan, and it takes quite a bit of time to actually run. So when you run it, it's going to take additional time. So what you're looking for in enumeration is, we know we've got the ports, we've got the services, we've got a pretty good idea of the operating system. But what we want to do is we want to look and see, can we determine what the actual, is there open shares? Is there open, the file system? Is it NFS, network file system in Unix? Those types of things. Are there things there that I can use to gain access? And that's what hacking's all about. So let's take a look at Nmap when we use this -A enumeration scan and what it looks like in Wireshark. So the first thing we're going to do is go into Wireshark and reset our display. It's always a good idea to reset your packet captures when you're testing this so you get to see how it works on a clean slate. So we'll do that now. Always clear any filters you have left over and click on capture, restart. Now we got a clean slate other than the normal Windows noise traffic. So now what we want to do is we want to do that -A scan. Now, as I said, this will take some time. So we take out that there, and then we just hit -A for those two targets. And we'll watch it as it's occurring on Wireshark. And you'll start to see, once again, it starts out just like it did before. Even, gets our two targets, gets the MAC addresses, because all data is delivered to the MAC address, as you may remember. And then once it gets going, so some UDP information there, it will start running an entire series of different scripts. So that -A runs a bunch of different scripts. So now you're starting to see it. It's doing the 443, the HTTPS 80. There's a bunch of your resets, as we said, a dead giveaway of a port scan. So it's just continuing to extract data and information from the target. But the difference is now it's going to run what's called scripts in Nmap. So Nmap has all these different scripts. And I encourage you, if you're not familiar with Nmap, to actually play with it and work with it. You can run it. In this case, I've been running it on Windows on my Windows 10 machine. And it's also in the Kali Linux distribution. But you can run it anywhere you want to practice and learn your hacking skills. And that's what you do. You hone your hacking skills. Once you now have a foundation, when you've got this far far into the Wireshark course, now you can actually apply what you've learned throughout the course to identify all these attacks and hacking techniques and perform them yourselves if you want to be a actual professional security tester like I am or something like that. So as you go through, we start seeing here in this case, you see it's doing a pass IE user. So if I right click that for the FTP, follow the stream, now I see it's actually using anonymous. It's verifying that the VSFTP daemon actually allowed the anonymous password. So it actually allowed, but then when it tried to do another command, it actually didn't actually allow it, where it says illegal port command and child died. Right. So these are the things you're going to observe when you're carrying out different hacks or somebody's carrying out different hacks against you. We're just following this same sequence of events that a hacker would typically do, or a pen tester, if they're targeting your organization. And we continue to see lots and lots of data coming because that's what the -A scan. In fact, the rumor is the -A scan has everything in it but the kitchen sink. That's coming in the next release. So Gordon Theodore Leone, who created Nmap, continues to add more and more features to it, where it's typically a network mapper, but now it'll even do some vulnerability checks for you using the scripts and those types of things. So now if we come back over here to our Nmap scan, we have a lot of data. And that data is telling us more about our machines. So now when you start looking at it, look at everything I have now. It's telling me, in this case, Samba 3.x, 4.x, that type of stuff. So it's giving me a lot more information. The Apache 2.2.8, the ISC bind, for those you don't know, the Berkeley Internet Name Domain, that's our DNS service. It's actually running on TCP 53 there, 9.4.2. It's also telling you that the ciphers allowed were SSL2. That's not a good thing. So all this data was extracted because the -A did more scripts. It ran more scripts to pick this up. So now you got the Samba here. We got a Metasploitable root shell, and the box is the Metasploitable machine. So that's just because it's deliberately vulnerable. So you see we have a lot of database here. We have a lot of data for our database. We have MySQL 5.0, a lot of different things. VNC protocol. All right. X11 open, but you can't access it. Apache JServer protocol. You get the idea. Now we come down to the next machine, right? So that's the Metasploitable. So we'll go back up to the other machine, 200 machine. We see it's the OWASP Broken Web Application Virtual Machine. So that's the machine that we're using here. Great actual training virtual machine for you. And you see you got Apache Tomcat Air, you got a Coyote, and you've got a lot of different things. So we've got a lot of information from the actual box. And that's kind of what we're trying to do here, is get information. All right, so now let's go take one more look at Wireshark. And a lot of data is in here, but remember our filters. So we just do flags.push = 1, and we know these are the only packets that had data. And as I've said before, I just like looking in the bottom window. You can do it either way you want. And I just start going through here and seeing if there's anything in that bottom window that I want to take a closer look at. And I already looked at the IE user with you, so I won't look at that. 200 OK for web stuff, that's pretty good. So I'll right click that and I'll follow TCP stream. And I see I got Apache Coyote 1.1 and those types of things. So this is the same process we've continued throughout. I just wanted to actually run the attack step, since a lot of people wanted to see more of the hack like a pro type stuff. But hacking is such a broad general term, we won't get into the concept. But hacking network packets is also a form of hacking, which is using Wireshark. So now that we've looked at this, let's go look at the next step. And we'll do that in the next clip. We're now ready for the next step. Well, what is the next step? Remember, we have live systems, we have ports, we have services. We've enumerated additional data. Now it's time for ID the vulnerabilities. You can use Nessus, OpenVAS, which is available in the Kali Linux distribution, or one of my favorite ones if we have web servers is Nikto. So what I'll typically do is do a scan just for port 80. And if I find port 80, I'll run Nikto just to get a quick look at it. So let's go ahead and look at this from a perspective. The first perspective will be Nessus. So we'll look at Nessus. So we're going to go into the Nessus tool, and you can go to tenable.com and you can actually download and install Nessus and get get a home plugin, which means you can use it at home, not for commercial use. And when I log into it, it comes up with its screen. I just go new scan. Now you'll see some of the scans you got to upgrade to be able to use. In this case, I'm just going to use the basic network scan. It says a full system scan suitable for any host. So I click on basic network scan. Right? I just give it a name. So in this case, we'll call it, we're going to try to save some time on it. So we won't spend too much time. We'll do Metasploitable. Let's do Metasploitable. That's our scan. Then we can put in description if we wanted the scan. And then we put in the IP address. And Metasploitable is 210. Once I've done that, I just click on save. Once I save it, it's in here ready to go. I just click on the play button, and that play button launches it, right? So we're just going to let it go because it'll take a while to do the scan. All right, so while it's doing that scan, we can start looking at Wireshark, and you start seeing lots of stuff happening. This is, for those you don't know, SNMP. So it's SNMP stuff, Simple Network Management Protocol. This is the OID, the Object Identifier. So that's what your SNMP traffic would look like, and SNMP, of course, is port 161. All right, so that's what that would look like when it's trying to enumerate with that. So we'll just leave the Nessus scan running. Remember I told you we had web servers. So let's go back to Nmap here real quick. And we'll do a clear screen. And let's just look for port 80. So -P port 80. And then we give it -SS because we want the fastest way possible because we're just trying to see if port 80 is open. And we got our two targets, 200 and 210. And there we go. We got them open in both places. Now we've already got Nessus scanning the 210 box. So let's go use another tool to scan the 200 box. And what I'm going to do is I'm going to use Nikto because Nikto is actually a great web scanner. I like it a lot. Now, the best way to learn about anything is man. So if you want to know about Nikto, you just put in man Nikto. And it tells you a bunch about the web scanner. I won't go through that. You can read that at your convenience. So I'm just going to go Nikto. I'm going to give it the target with a -H option. And then give it to 192.168.177.200. And then -output, I want to make an actual report of it. And I'll make the output Udemy Nikto. So I know it was from my Udemy class. And then just .html. And that will create an actual HTML file. So you see now it goes out and it tries all these different requests to look for if there's information in there that can potentially be a vulnerability. You see it's got possibly a system shell found and other types of things. So it's got quite a few different things that it's potentially found. All right. So as it's going through that, remember, we still have our Nessus scanner going to town, so we can go check our Nessus scanner while we're at it. So we come back over here to our Nessus scanner, and we see it's still scanning, and we can watch it live. So if we click over here right now, it's just found 3 medium vulnerabilities, so we'll leave it go for a while. Just go back to our scans, keep it going. Then come back to our Nikto scan, multi-threaded here. Now Nikto's finished, right? And the key is this right here. TikiWiki contains a vulnerability which allow remote attackers to execute arbitrary PHP code. Now, the downside of this is we're reading it in text. But remember, we saved it as an HTML file. So now I just go here, bring up Firefox ESR in this case, and I'm going to look for the vulnerability. So now I just press the Alt key, file, open file, and now I'm looking for my file I created, and we called it Udemy, so it's going to be down here at the bottom, nikto.html, open. Now there's a nice HTML output file for the findings. And as we start going through here, we see the different findings and some information, and this is what you would do as a professional vulnerability assessment or penetration tester or security tester. You'd take all these findings, draft them, write them up, and map the attack surface of your targets. And once you know the attack surface, you prioritize which one you want to attack. And as I said, this one, the one that's interesting here, is this TikiWiki formula, right? So that's the vulnerability. So now we can go back to Nessus, see if that scans. So we got that vulnerability that we need to take to the next step. Nessus is still scanning, and he's got some red now. So Nessus has found some critical things. He's got a VNC server password, so that's pretty easy to log into. He's got a rogue shell backdoor detection, and he's got Debian OpenSSL package random number generator. So great things, good findings. So we go to Wireshark, and Wireshark is just off the charts now because we ran both a Nessus scan and a Nikto scan, right? Now, the nice thing about the Nessus scan is it was web traffic. So we just click on statistics, HTTP requests. And there it is. We have all the traffic sent by the Nikto scanner, right? Which is kind of nice. So a lot of good information there. Right, so you see how that works. And I won't go through it all because I covered it all earlier in the course as well. So we now know that we have 2 targets, and both our targets have some vulnerabilities that are critical. The TikiWiki one for this one, and as Nessus just said, the Debian OpenSSH and those types of things. So we go back and we see if our scan's still going, and it is. And once the scan completes, then we'll actually look at the actual vulnerabilities and then look from the next level. But we have enough now to gain access. So as we're doing our attack surface, we're looking for things that gain access. Remember, we had the TikiWiki, now we have the VNC server password of password. So we could get access either way, and it's showing us here in the output Nessus logged in using a password of password. All right, so now this is what we want to do. We're going to go to the next step. So we'll go ahead and stop this clip here, and the next step will be exploitation, and we'll cover that in the next clip. So we've carried out this entire scanning methodology. We found live systems. We have 2 targets, 200 and 210. We did a port scan, stealth scan, and a connect scan. We looked at services. We looked at enumeration, and we ID vulnerabilities both with Nessus and with Nikto. And the same process would apply with OpenVAS as well. And that's why it's so important to just understand the process, because the tools and what tools you use come with experience after doing it over and over again. And what I recommend to most people when I train them is pick 2. Pick 2 tools you're comfortable with and focus on those and master those 2 tools. And that's the key to being a professional security tester. So now that we have the vulnerabilities, the next step is we know all systems will pretty much have vulnerabilities in software as well. But not all vulnerabilities will have actual ways that we can validate the vulnerabilities. And that one step of penetration testing is validation of vulnerabilities. And that is exploit. So now what we're going to do, taking the actual just the Nikto scan, because we had the Nikto scan with the TikiWiki vulnerability, we're going to actually take that one and we're going to try and exploit it. So let's go ahead and see how that's done. But more importantly, see what it looks like in Wireshark. And Metasploit is one of the most popular tools. So we're going to start MSF Council, which is the Metasploit framework, which is an exploit framework. So we'll open another terminal window here. When we open that terminal window, we can actually search for an exploit locally on the Kali machine and not even have to go and look at Metasploit. And we just type in the term what we're looking for. So we found TikiWiki. So we do a search exploit, TikiWiki in remote. I don't really care that much about a local exploit. I want a remote one. And now we do a search and we see, wow, we have quite a few different ones. Now what I look for here is something in a programmable language like C. In this case, I got Ruby script, PHP, and text files. Now by all means, you can play with those and actually make those work. But in this case, since I don't have a C program, I just go over to Metasploit and say, well, will Metasploit help me any? So I do the search on Metasploit, and I search the same thing, TikiWiki. Now, it's telling me not built because I told you I didn't actually start the service Postgres, the Postgres SQL server. So the database cache isn't built yet. So that slows down the search a little bit. But for our case, it's not really that much of a slowdown. But while we're waiting on that, let's see if our Nessus scan provides us any other information from what we found earlier. In this case, I think we just maintain the same 3. So we still have the same 3 vulnerabilities. Now, the VNC password's pretty easy. We could just log in a VNC client. Wouldn't see a whole lot of information in Wireshark. Speaking of Wireshark, let's go over there. And as always, let's restart it to get us a nice fresh capture to look at our network traffic. Come back over to Metasploit and see, oh yeah, it has lots of vulnerabilities on TikiWiki that have exploits. Now, the only one we want was the graph. So what we're looking for is the graph formula, and there it is. So now the way we actually do this exploit, we just highlight it. Once I highlight it, no Control-C, you got to right-click it to copy. And I just type use, and I right-click, paste, and see, I forgot the E there, so make sure I go put that in, or it's going to typo me. Now I'm in the exploit. If I type info, it tells me about the exploit and how it works. TikiWiki contains a flaw that may allow a remote attacker to execute arbitrary PHP code. All right, great. So now all I do is type show options. This tells me the options that have to be set. So as you see, required, yes. The only one that's not set that's required is the target address, otherwise known in Metasploit as rhost. So I just set rhost, and I put in the IP address. Now, comes down to, is it a good exploit day or a bad exploit day? Some days it's good, some days it's bad. In this case, we're trying to execute it, completed, but no session created, so we try it twice. And the second session worked. So the first session failed, if you noticed that, but the second session did work. Now, what you want to notice here is the actual interpreter session that's opened is on port 4444, and that's the default port for Metasploit. So a lot of times I tell people when I'm teaching them on defense is block port 444 from the internet. Well, 44 is 4444, and block it outbound and inbound both. Because if you get somebody who doesn't know a lot about changing the actual parameter, set L port to 123. I like to use network time protocol and try exploit to try to do it again. Now I've got another session, but you see that session is on port 123. So if I background the session and I do sessions -L, that's the list of my 2 sessions. So this is a lot of information, good information actually, that you can use, but it's not part of what we're doing within Wireshark. But what I want to do is now let's go to Wireshark and look and see what we see if an attacker on our network is using Metasploit and Meterpreter. So we just tcp.port equals 4444. There's the 444 traffic. So there's the 3-way handshake. So we right click, follow the string, and guess what? We see PHP, function exists, so we see all the PHP code. So we see all the PHP code, all that PHP code, all that information. So we have some data that we can actually reflect and look at, and then it's encrypted. So at that point, when it gets the attack in there, it becomes encrypted because the Meterpreter shell is encrypted. All right, so you're seeing in here, my print finished, and then that's where it actually gets into that actual graph formula, and it encrypts it. And remember, we had 2, so we could actually clear this, and we could do TCP.port equals 123. All right, so now you see, even though it's not network time protocol, Wireshark doesn't know that. So now you see what hackers can do. They can pretend to be a protocol that's allowed, and your monitoring devices will think it's actually that protocol unless they inspect into that protocol directly. And that pretty much is hacking like a pro and looking at Wireshark as you observe different hacks. So now not only do you how to do actual network hacking because you've learned all the protocols and things throughout, you've had an introduction to how a hacker would actually do an attack and go into the live systems, the scanning methodology, live systems, ports, services, enumeration, ID vulnerabilities, exploitation, and also what it looks like in Wireshark. So we've taken it the full circle. Remember that one step, exploitation or validation of vulnerabilities, that's penetration testing. So now go out, practice, and work through the process. Once you have the process, play with the tools. I always like to get 2 to 3 tools and master those tools, and it makes you an actual professional security tester. And that's it. Enjoy. In this demonstration, we're going to review the network traffic from going to a website and downloading files. I'm adding this to the course after having several questions about extracting files from a network capture file. In this example file we have here showing the results of several connections and downloads of files that have been conducted over the protocol HTTP are represented. As you probably know, if this is over HTTPS, we would have a different look to the data, and we'll review that as well coming up later. The quickest way, and the first way to try and extract the files, is let the Wireshark tool do it for us. Once we have the capture file of interest, we can extract the objects out of it. So we'll attempt this now. In this capture file, we go over here, we click on File, Export Objects, and then you see we've got a number of different protocols here that we can use. So all we're going to do in this case is HTTP, and this shows us all the files that are actually represented in the trace. As we see here at packet 71, we got an icarm.com.txt. Some of you might know that's the antivirus test file. Then we have a WP SMB plugin.pdf, so we have a PDF file. And then down here at packet 19,684, we have an actual PCAP file. So what we've got here is different types. So you see application PDF, text, HTML. So this is how you would actually identify files that you want to take a look at. So if we go here and we select one of these files and we save it, it'll come up and save as the name that we're going to give it. Now, normally it's going to save under Wireshark, so we'll move it there, and we'll just save it as test1.pdf. That makes it easy to find. So now we've done that, and then we close. Okay? So now we have the file. This is the actual information here for the file, and that was the process. So now once we do that, we would actually go look at the location where we saved the file to. But before we look at that, let's show you for some of you what it would look like. After Wireshark 1.5, it's now this method of file export objects is there and available for us, which makes it much easier to do. But before that, you would have to manually carve it. So we'll just show you some of the steps of how the actual manual carving process would work. So what we would do is we would actually get in here where the file's at, this application PDF packet is 17,518. We right click it and we follow the stream. Either one, TCP or HTTP is okay. And as you see here, that PDF, that %PDF actually represents the header of the file. So you have to go from the header of the file to the tail of the file. And that's where it gets a little tricky, because in this case, there's 4 different possibilities for the tail of the file. But as I scroll down here, you can see we've got the file contents, and then we get into the actual encoding of the file content. But you can see the actual font type, true type, base font, Calibri, those types of things, italics. So you have quite a bit of information there. Then down here you get into the encoding, and then what you have to do is you have to take all this data here, put it into a hex editor, and find the trailer. And once you find the trailer, then you would actually go about trying to extract it. Now, it's a little bit beyond the scope of what we're trying to do in this demonstration, but if you do want to see that and want me to add that as a future type of demonstration, then by all means, send me a message, and then I can add it into one of the other ones. But for now, we'll just leave it as that. So now that we've done that, we'll go look at our file. So if we go to the D file, and there's our test1.pdf. The file opens, and it's good to go. Okay, so now, this is much easier when it's a text file. So if we go back here to our file, and we go export objects, HTTP, and we do the first one, which is the iCar file. So once we do the iCar file, that's packet 71, as we're showing right here, and we right-click it, follow the stream. Now what you'll see is the connection and actually the contents of the file. And this is the contents of the antivirus test file right here. So that antivirus test file is used to test antiviruses. So if you actually go try to do it with this file, your Windows Defender or your antivirus software will delete it. So just be aware of that. I had to disable it to be able to actually download the file. So now what we want to look at is what happens if the connection is HTTPS. All right. So if it's HTTPS, then we're going to have a little bit of a challenge. So since we know we can use that, we'll go and take a look at it here. So I've actually created another file. If I go File, Open Recent, I've got another file, and here's the exact same iCar extraction, but this one's using actual transport layer security, as you can see here, TLS version 1.2, which means it's using HTTPS when it connects to the internet. So now when we go File, Export Objects, we don't have an HTTPS because we can't export. You see, there's nothing in the object list. So this is the exact same actual download of the iCar file, but it's done over HTTPS. And because of that, we don't have that. So if we close this and we try to find it in the actual network trace itself, we can go through and look and try to find it. And we just right click and we follow the stream, and it's all encrypted. So there's no way we can extract the data out of the actual file. So what you've seen is by using HTTPS, it makes it much more difficult to monitor or do anything. And that's one of our defenses against interception for confidentiality, breaching confidentiality, is to use encryption. And what we've shown here is if you use encryption, then you can't extract the file. So very important that we use HTTPS. And the good news is, after the last attacks and everything, we do have HTTPS pretty much being used. And that is the process of how we extract files using the Wireshark tool. As I said, Wireshark is very powerful unless it's encrypted. If it's encrypted, then we can look at some things, but you're going to get into places like this, like where we've got this quick UDP internet connection encrypted, and we go in here, and we got nonce, a random number generator, and we got a payload, but we have to do some form of decryption or decoding to be able to extract that data. And that's the goal as a security professional. We want to make it not clear text. We want to make it harder for the perpetrators or the attackers to be able to extract the information. So what I want to do here is show you how to extract files with Wireshark from PCAP files that HTTP has been used in. We also can do this in SMB. So if we go in here and I bring up my SMB packet capture, I've got an SMB packet capture. It's the same process. I go export objects. Once I go export objects, I go SMB now instead of HTTP. So once I select SMB, there it is. I see I've got an actual plugin. It's a PDF file. It's the exact same process we already followed. So it's just using SMB now. So if we go to the follow TCP stream, it's no longer HTTP. You can see all the Windows stuff in it, Contoso server, which is the standard one for Microsoft. And now we're doing the SMB communications. And we start getting the information, the object information down there. And we start seeing the data, and the data is a PDF. And that's pretty much, now it's the same concept. It's just now we're using SMB as the protocol to transfer the file, like a file server. This is like a file server would do. Then what you can do is you can actually get the different components of the conversation. So you can get that component of the conversation, or you can get the other side of the conversation, and then you can actually look at it in raw data. If we go look at it in raw data, now it's showing that this is the raw. And what you would do is you would take this raw data, put it into the hex editor, go from the actual point of the header, which in the case of PDF is %PDF. And once you've done that, you'd find the trailer. Once you find the header, cut out the header from the header point to the trailer point, and that would be your file. You'd actually extract it, save it, and then open the file. And that's how we do some forms of malware analysis to figure out what files have been transferred by the malware. But again, that's beyond the scope of our demonstration. If it's something you want me to add later, I can always do that. And at this point, we'll conclude the demo.